This is RD Sharma Solution Class 12 Chapter 18. We are taking exercise 18.5 of Maxima and Minima. Now these are the questions based on sentences, English sentence language, and then we have to use those sentences to form the actual thing which we have completed in 18.1 till 18.4. We have to form the expression using these sentences, and the rest remains the same. So we have to determine two positive numbers whose sum is 15 and the sum of whose squares is maximum. Now this first line is determine two positive numbers. So the numbers has to be positive. It's not saying what kind of numbers, just two positive numbers. And sum is 15. Sum is 15 if you take x as one number, the other as y. The sum should be 15. X is greater than 0, y is greater than 0, that I already explained. So now you can take one as x and one as 15 minus x, because y from this expression is simply 15 minus x. Then we have sum of squares, so x square plus y square. X we have taken one number, y is another number. We squared them and we said that whose squares is maximum. We'll see whether it comes maximum or minimum in a short while. But the sum has to be maximum, and this equates to z. Z is the maximum or minimum, that we'll see just now. So how do we go about it? Because we have already formed two expression using the two sentences. Minima, maxima is always computed using the dy by dx, that is the differentiation. Differentiation is equal to 0 is what gets you the critical points. Those critical points are important to find out the maximum and minimum value. One value we have taken as x, the other will be 15 minus x. Two values are x square and 15 minus x whole square. So in place of x, in place of y, 15 minus x whole square. Now rather than opening it, it's better that you can just differentiate it right now, or you can open it. A minus b whole square, a square plus b square minus 2ab. Finally you got 2x square when we expanded, 2x square minus 30x plus 225. This is the expression we got after say expanding 15 minus x square. But the thing is that it can become easier if you just differentiate with x square plus 15 minus x square. That we'll see in the later questions also. Because this is the first question, I expanded it. I'm now differentiating it. 2x square will be 4x minus 30. 225 will be 0. So this dz by dx is 4x minus 30. In order to get it as maximum and minimum, we have to equate it to 0. That means 4x minus 30 has to be 0. X will be 30 by 4. And 30 by 4, if you just divide both numerator and denominator by 2, it will be 15 by 2. It's just the half of x. So what will be y? It will be again 15 by 2, because 15 by 2 will make 15. I am not differentiating, redifferentiating. That is the second differentiation I am doing. It gives you 4. That 4 is simply a positive number. And this double differentiation will give you the minimum. Now you will raise a question that maximum value or maximum only comes when you have negative, and positive gives you the minimum value. And we are supposed to find out sum of the squares is maximum. But we don't have to go to this d2z by dx2, because we have found the critical points and there is only one critical point. We cannot go here and there. We have no option left. We are just with x equals to 15 by 2, y also comes to be 15 by 2. And x and y is 15 by 2, z is simply 15 by 2 whole square plus 15 by 2 whole square. That will make the whole expression highest or maximum. So we can say that 15 is divided into 7.5 and 7.5. As I told you, they were just positive numbers. It was not mentioned it is an integer or a decimal number. So whatever we explained, it is here. Don't bother about d2z by dx2, that is the double differentiation. We just did it just to show that because maximum and minimum is required, sum of whose squares is maximum. So that is how we get the maximum minimum. And since it is coming as 4, I just rest my case and I just go with the numbers which we have. So there are two positive numbers, you square them, there will be positive square, and that will make them most maximum. Divide 64 into two parts such that the sum of the cubes of two parts is minimum. Again 64, as we just have witnessed, two numbers can be divided as x and 15 minus x in the previous case. One can be x, one can be 64 minus x. So if you have whole line like 65 numbers, if you take some of them as x, the rest will be 64 minus x. Either you can do x plus y equals to 64 kind of thing which we just did in the previous question, or you can say simply one is x, one is 64 minus x, which is more realistic also. And from this expression x plus y equals to 64, it will also give you 64 minus x. In both the cases, x and y will be x and 64 minus x. This is the first part we have completed. We have divided 64 into two parts. The second part is saying such that the sum of the cubes of two parts is minimum. Now we are not worried about minimum, maximum. We are more worried about the critical value which we get. So x cube plus 64 minus x whole cube, because the cubes are being talked about, and this is equal to z. Now let us just differentiate it. The next thing which comes is the differentiation. When we differentiate, you get x cube plus 64 minus x whole cube. In the previous question, we expanded 64 minus x whole cube. There are certain people who might not remember the cube formula just now. They will just recollect it, and that will take time. It's better that rather than expanding it as refer to the cube on the power, we can just differentiate it. So x cube differentiation is 3x square. 64 minus x whole cube is 364 minus x square, means square to this one. And 64 minus x is going to give you -1. So it will be 3x square minus 3 into 64 minus x whole square. This is the whole thing which you are going to get. Now the next part comes when we are already at differentiation. We have already done differentiation. The next one goes as equating it to 0. When we equate it to 0, those both part will be on either side. 3x square is going to give you 3 into 64 minus x whole square. Negative was already there, so we just transferred it. Now what will be the better way? Just cancelling this 3 and solving this, or rather there can be some other way also. I'm just expanding it. 64 minus x whole square, 64 whole square is 4096, x square is x square, and minus 2 into 64 into x is minus 128x. When we cancel this, we'll get x as 4096 by 128, and that will give you 32. 12, 128, so you're going to get 32 here. The other number will be y equals 64 minus x. So 64 minus 32 is again 32. We have seen in the previous question also that it was 15 by 2. So when we divided and we wanted it to be minimum or a maximum, then we already found that it has to be divided into two parts. Next one is d2z by dx2, that is the double differentiation of a differentiation. We are again differentiating it, and since we are already we have already done the differentiation part, we'll do the double differentiation as well. This double differentiation will give you the certain expression in which you have to put this x as 32 and try to find out whether we get negative or positive. Incidentally, we may get negative or positive, we'll just see. I'm just replacing this x by 32 right now. And this x equals to 32 is going to give you d2z by dx2. That will signify not the value but the sign. And that sign will indicate us whether it is going to be minimum or maximum, because the negative means maximum, positive means minimum, that we have learned in the previous exercises also. Once you compute this, what are you going to get? You are going to get a proper value, but we are more interested in finding out whether it is negative or positive. Negative and positive will give you the proper idea. But here, if you see, it's coming 384, and 384 is actually positive, and positive means greater than 0. Greater than 0 means we are talking about a minimum value. So there is a slight change, or you can say the previous question should be minimum, and that we have seen that previous also we got 4. So I would like to change the previous question and this question also. Previous question was minimum. If it would have been maximum, then the things have changed. So there was no mistake at all. This is all the correct thing which we have done. How should we choose two numbers each greater than or equal to -2 who sum this so that the sum of the first and the cube of the second is minimum? Now x and y, we have to choose two numbers each greater than or equal to -2. They can be equal to -2. They have to be greater than or equal to -2. There are the only two possibilities of choosing those numbers. The second thing the second part of this question is whose sum is half. This is given in the question, so I am writing it here. The question is saying the sum should be half, so that the sum of the first and the cube of the second is minimum. As we have x and y, that two values are the variables we generally take when we have two variables, x and y. When we have third variable, we take it as z also. But x plus y is given in this question as half. X plus y is half. Now you are getting x, you are getting y also. Y is simply half minus x. There are two ways. If you do x plus y equals to half, you have to take one more step. Coming to the third part of this question, which is saying the sum of the first, which is x, and the cube of the second, which is y cube, is minimum. So from here from the first part, you can say x we got, y is half minus x. Now we are replacing this x and y in the final equation, which is z equals to x plus y cube, which has to be minimized or maximized. Half minus x whole cube, rather than actually cubing it, it's better that we just differentiate it. Opening it will take time, and we have to eventually differentiate only. So thrice of half minus x whole square, x will be 1, so I'll just put a 1 here, and this 3 half minus x whole square will be 3 into half minus x to the power 2, and differentiation of half minus x will give you negative 1. Finally, what we got? 3 into half minus x whole square equals to 1. Half minus x whole square is equal to 1 by 3. Half minus x will be equal to plus minus 1 by root 3. It's root 3, I'll just change it, because when we take square on the other side, it has to be plus minus, and it has to be covered with a root, like a cap. So one time we got half minus x as plus 1 by root 3. One time we got half minus x as negative 1 by root 3. Now the question arises, which of these two values has to be actually used in order to find out which is the better value, or which is minimizing the actual expression, which is x plus y cube. Finally, we can write x as half plus minus 1 by root 3. I'm just combining the two values so that they go along. They go together. Next one is d2z by dx2, which is the simple differentiation of the differentiation. Double differentiation. That will give you the sign. So we are interested in the sign in this particular case of the second differentiation. I'm differentiating. I'm not saying what I'm differentiating, but you know that I'm differentiation of the second differentiation I'm doing. So this is the second differentiation, and this will simply be, because of course one is going to be 0 and half minus x whole square is already there. So it will be 6 half minus x to the power 1, and negative x half minus x differentiation will give you negative 1. Negative was already there, so negative will make positive. Finally, you will get 3 minus 6x. Now this 3 minus 6x, now you have to place half minus 1 by root 3 one time, and half plus 1 by root 3 one time. When you place half plus and half minus, you will see the sign. The sign where we get positive value, that will make this expression minimum. I hope you got the idea. In the previous two questions, we were talking about getting it minimum. So we got the positive values when we did the double differentiation. Here, it's simply certain values I'm putting, and when we place certain value, we need to have a positive value. And here we got the positive value. If it is coming as the positive value, when we place half plus 1 by root 3, we're going to ignore half minus 1 by root 3 straight away. This is the value negative. And since negative value and positive value, see, negative value will give you what? It means that it will be maximum. But positive value will give you the minimum. I hope you have the difference here. So please remember, in this half, I'm not saying what you have to put, and I'm not putting it also. I'm just saying half plus 1 by root 3 and half minus 1 by root 3. Just place that value, or place both the values, and take only that value which can give you the minimum value. That is, it has to be positive, and positive indicates the minimum value. 3 minus 6x is there. If I place this value, what are we going to get? See, if you place certain, again I am reiterating, I am not saying you to put certain value. I'm just saying to put value and find out the sign. The sign has to be positive in order to get it. When you place half minus 1 by root 3, you got positive. This is greater than 0. And greater than 0 means it is strongly recommending us that, oh, this is going to be minimum. So the whole story is half minus 1 by root 3. And x is this value. d2y by dx2, we got 6 by root 3, which was actually positive. And positive is indicating that this is going to be minimum. And we are interested in the minimum because the question is saying the x square plus y cube has to be minimum. So we are going to take that value only, which will make this as minimum. What is the x value? X already we got. Y is simply half minus of this value. So when we place this half minus of minus half and plus 1 by root 3, it is going to be plus 1 by root 3, because half of is going to get cancelled. Half minus half plus 1 by root 3, half of gets cancelled. You get 1 by root 3. 1 by root 3 is the final value which we are interested in. So this is 1 by root 3, and this x and y we have received, and these are the final values. You can just stop it here, because we need minimum. As I am reiterating again and again, this simple logic is to check for both the values, get the value which is greater than 0, and when you get that value, that is the final value which you can give it to x and y, and you can say that x and y are probably this value. So the required numbers are half minus 1 by root 3 and 1 by root 3, which will make this as minimum. Divide 15 into two parts such that the square of one multiplied with the cube of the other is minimum. Again 15 has to be divided. Again we are eyeing upon the minimum thing. So we have x and y. As I said, you can just do this in the way we have dealt with the question having 15 as the number. One will be x, the other will be 15 minus x. That is the whole idea which we pave upon, or which we walk upon. X and 15 minus x are the two numbers. This is the first expression, always run, because x plus y is 15. That is how we came up with x and 15 minus x. The second one is the square of the first, x square, and the cube of the other. What is the cube of the other? Minus y cube. So it's y cube only. No minus, it's just multiplication, because they are saying square of 1 multiplied with the cube of the other, x cube. And now I am replacing y by actual 15 minus x, which we have already talked about. 15 minus x whole cube. Now this square and cube, rather than actually multiplying and opening it, it's better because we have to differentiate eventually. Differentiation, we will take the product rule. First we'll take the first one, differentiate the other one, then we place a plus sign, then we differentiate the second one, place the first one, like that. Finally we'll get an expression. This expression we are not going to stop. This expression has to be placed or equated to 0 in order to get the critical point, and that critical point will be the deciding factor, and that deciding factor will give you the values which we started with x and y. Again I'm saying differentiation is all what I'm doing just for the sake of completion. Differentiation is your responsibility, which you owe me, because differentiation is already known to you. Now both the sides we have equated, and this is the way I'm doing. Most of the people will do it like this, and you will see that you will land up with a problem. If I cancel both the sides, like I divide both sides by 15 minus x, I divide both sides by x square, like this. But what you are going to get here, you will just see one value you will get, and that is the correct value also. You will see that what I'm suggesting here is the value you are getting by this just equating and cancelling things randomly. X is 15 by 2, that is 5, 6, 30. X is 6. What will be y? Y will be 15 minus 6, that is going to be 9. So x and y we got, but this is not the right way. I'm just saying that this will also give you the correct answer. But the whole idea is the mathematics is not done like this. We have to find out all the possible values, all the critical points, because x equals to 6 is just one of the critical points. Now what I'm doing is I'm taking the right expression to the left expression, and now I'm rearranging it and trying to find out trying to see, are there other values along with 6, or 6 is the only value. So I'm just taking these again on the left hand side, all of them. Now I'm taking 15 minus x common. When I take 15 minus x common, I'm pretty sure that x equals to 15 will be one of the critical point. I'm taking x outside, that will be x. So x equals to 0 is another critical point. And what is left inside? Whatever is left inside is what we have already done. See, 30 minus 2x, or 30, this will be 15x, 5x basically. Minus 2x and minus 3x will get combined. It will be 30 minus 5x. Okay, now when we are equating it to 0, x is equal to 0, 15 minus x equals to 0, and 30 minus 5x equals to 0. 30 minus 5x equals to 0 is already being witnessed by us just a few seconds back. But 15 minus x whole square and x was not there. I am saying you were on the correct path, but I am just saying that you have to tell the examiner that there are other values also which we found, but they are not relevant to the question, because 15 minus x will give you, if you equate it to 0, will give you x equals to 15. So when x is 15, y is going to be 0. You cannot take that. When you have x equals to 0, what does it mean? Y will be what? It will be 15. So you again cannot be taking that, because 15 and 0 is not the part. You have to divide 15 into such that it has to be two parts. So 6, 9, or say 5, 10, like this. So two parts that will give you the expression, and that expression has to be minimum. So now we got 6 and 9. I hope you got all the explanation which I gave. 0 and 15 cannot be taken. X equals to 16 can be taken, and y is equal to 9, because x is 6, so y will be definitely 15 minus 6. That will give you 9. The next step is to differentiate, double differentiate. I am not differentiating the differentiation. Again, I am not telling you what I am doing, because this is your responsibility. Double differentiation is simply the differentiation of the previous differentiation. When I differentiated it, and when we place x equals to 6 here, what is the value I am getting? I need to get a positive value in order to find out, or say strongly that we are going to get a minimum value. So when you just see after placing x equal to 6 in the double differentiation value, you get negative 2430. Negative is less than 0. Negative is less than 0 means you are going to get negative is maximum. Again, here is this situation here, because we are talking about minimum, but don't worry about that. Even if you are getting less than 0, z is maximum when x equals to 6 and 9. So the question I need to change, I cannot change because the question is like that. It is given already in the book. But when we take this d2z by dx2, we are not convinced. I am not convinced actually. So there will be certain questions which can deviate your intelligence. But I would suggest you that what all practice you have done, that is the single differentiation, double differentiation, placing it to 0 and finding out the sign of the double differentiation, that will land up you on the finding of x and y, which is the value which is to be placed here or to be found out. Don't worry about minimum and maximum here. The question in the exam will truly be tested and then it will be provided to you, because here negative simply means that you are going to get maximum value, which is not the case here. I hope the first question was like that, the fourth question is like that, and other questions will be like that. But our idea should be simply straight, differentiate, double differentiate, and then just find out the value. Of all the closed cylindrical cans, write circular, which enclose a given volume of 100 centimeter cube, which has the minimum surface area. Now what you see here is, we are talking about a cylinder which is a right circular cylinder. What is the volume of the cylinder, which is already given in the question? 100 centimeter cube. This is the radius, this is the height. If we take any right circular cylinder, now what is the volume? It is pi r square h, pi into radius square into height. And this is given as 100, so we'll equate it with 100. Height will be 100 divided by pi r square. This is height. Now coming to the surface area, minimum surface area, talking about surface area. Surface area is the whole, this area, this is outer area or a curved surface area, plus the surface area of both the ends, which is pi r square plus pi r square, 2 pi r square plus 2 pi r h. Now surface area we can write it as 2 pi r square plus 2 pi r into h. And what is h here? 100 divided by pi r square. Now what do you see here is 2 pi r square. Now you just cancel this, you will get 200 by r in this case. Now the second thing is to differentiate this, because we are intending to find out the minimum and maximum of surface area. So surface area needs to be differentiated. I am going to differentiate it right now. 2 pi r square plus 200 by r. 2 pi r square is 4 pi r minus 200 by r square. This ds by dr has to be equated to 0. So ds by dr equated to 0, we get 4 pi r equals to 200 by r square. When we take this, this is going to be r cube. R cube is equal to 200 by 4 pi. We are getting r cube equals to 200 by 4 pi. So r will be simply equal to 4 pi divided by, or 200 divided by 4 pi to the power 1 by 3. Now you can just cancel this 4 with 200, you will get 50 by pi, and this goes to the power 1 by 3. This is the radius, and this is the final answer I am telling you. But we will not stop here, because we have to say that it is minimum also. For that we need double differentiation. We are differentiating this expression again, 4 pi, and here we will get r cube. So it will be minus will be plus 200 by r cube, and this is going to be 400 it will be. Now what do you see here? Radius cannot be negative, so this whole will be positive. This whole expression is positive. So d2s by dx2 is actually greater than 0. So you are going to get a minimum surface area, because we have verified that it is going to give us the minimum value. What is the radius? It's 50 by pi to the power 1 by 3. This is your answer also. But once we are at a radius, we need to find out the height also. Height is 100 by pi r square. And this r square goes to 50 by pi to the power 1 by 3. 1 by 3 into 2 is 2 by 3. Now this 100 by pi can be written as 50 by pi, that is 2 into 50 by pi. When you have 2 into 50 by pi, this 50 by pi in the denominator goes up, which is minus 2 by 3. So 1 minus 2 by 3, let me show you what I am trying to say. 2 into 50 by pi, 50 to the power 1. 50 by pi, this goes up, minus 2 by 3. 1 minus 2 by 3 is 3 minus 2 by 3, that is 1 by 3. So what do you get? 2 into 50 by pi raised 1 by 3. This gives you the height also. We have the radius also and the height also. So this is the reference for you, and all the language we need to follow from here. A beam is supported at the two ends and is uniformly loaded. The bending moment m at a distance of x from one end is given by this one. Find the point at which m is maximum in a given case. Now the next question also is exactly like this, so you have to follow this diagram very carefully. This is the beam and the beam is also supported and the load is uniformly balanced, and you don't have to go into the basics of the physics which is being provided here. We have to stick with our minima and maxima kind of thing, what we are actually going upon. This, if this part, one of the part is x, the next part will be simply the distance minus x, but we don't know the total distance. You can call it as L. So L is the length of this beam, which is given in the question also, and W you can call it as weight. M is the moment, bending moment. Moment is one kind of force. It's kind of force. So already M equals to WL by 2x minus W by 2x square is given. We will simply differentiate it. And when we differentiate it, we'll put it as 0. That is the first step we generally follow. We have WL by 2x already differentiated. W by 2x square will be 2x. 2 gets cancelled. WL by 2 minus W into x. This is our differentiated value. Now the second step after differentiation is to equate this to 0 in order to get the relationship between x and L. X is what we have seen from the question. L is also from the question only. So there is a relationship between them and we have to tell the relationship or the value of the x, which is in terms of L, which is L by 2. X is L by 2 in this case, that is the total length divided by 2, that is the half of the length. So we have talked about the half of the length. X is L by 2. Now we have to also show that M is maximum. We need to differentiate it again. dm by dx has to be differentiated again. WL by 2 will be 0 minus W only will come. Negative means W cannot be 0, but it is a force. And say weight. Weight cannot be negative. It is negative, that is you are going to get a maximum value. And maximum is going to come and at x equals to L by 2. This is the complete solution in front of you. All the English sentences you have to follow from here. And the logic I already provided to you. You can just follow that logic. This question also involves the same logic. There is no difference, only the difference is in the expression. Previously the expression was in square. This we have the expression in cube. So we'll get a slightly different value of x and L. That is, we are going to find out the value of x which is pertaining to L. Now dm by dx we have to do, that is the differentiation of this expression. Once you differentiate this expression, you are going to get this. This is not x. I'm just cancelling it. Wx by 3. When we differentiate it is going to be W by 3. And this is minus W by 3. And this x cube will be 3x square. You get 3x square. L square remain the same in the denominator. This 3 gets cancelled. You get W by 3 minus Wx square by L square. Please remember this W is in the capital letters. And we need to equate it to 0. That is our next step. dm by dx is equal to 0. When we equate it to 0, we'll get a relationship between L and x. So L and x, what do you get here? This gets cancelled. X square equals to L square by 3. X is equal to L by root 3. That is, x square is equal to L square by 3. And we have taken under root on both the sides. It will give us L by 3. This L by 3 is the value of x. And this is the answer, L by root 3. But we don't have to stop here. We can stop here, but the question is also asking about maximizing the m. So d2m by dx2 we are doing. Already the expression is in front of you of single differentiation. The double differentiation, W by 3 is going to be 0. This minus WL square will remain like this. X square will give you 2x. So all this right hand side is positive. The left part which is negative. All those right part will always be positive. So this is negative in entire case. So this is going to give you maximum. This is the value of the maximum at x equals to L by 3. All the English sentences you have to follow. A wire of length 28 meter is to be cut into two pieces. One of the pieces is to be made into a square and other into a circle. What should be the length of two pieces so that the combined area of the circle and the square is minimum? Again, there is a question coming exactly like this. You need to follow this question very carefully. If one part we have taken as x, the other part will be of course 28 minus x, because we know that x plus y is 28. If we take 1 as x, y will be 28 minus x. So x and y we generally take, one is x, one is 28 minus x. Now the second part is that this whole piece will be made as a square and the remaining piece, which is 28 minus x in the case, will be made as a circle. And what is the side of one, because square has all the equal side. So when we add the four sides, you are going to get the x. That is the perimeter of this square is actually equivalent to x. Side plus side plus side plus side. So 4 into side is equal to x, because this x will be made into a square. So 4 into side is equal to x. That means the side is equal to x by 4. We are not interested in any other thing. We are interested in anything which is pertaining to x, which we have imagined. or which we have guessed. What is the circle? Circle area is pi r square. Area of a circle is pi r square. You already know what is the pi r square, but before that we need to talk about the area of square, because we are talking about area of square. Area of square is just side square, and side is already x by 4, which we have just seen. So side square is x by 4 whole square. It is going to be x square by 4 4 is 16. X square by 16 it will be. This is the area of circle, area of square. Now coming to the area of circle, which is going to be pi r square. Now we are interested in the radius of this circle. Radius of the circle is computed by the perimeter of the circle, because 28 minus x is going to be formed as a periphery of the circle, or the circle will be formed only by that 28 minus x, that kind of piece. So 28 minus x is the perimeter of the circle, and circle perimeter is simply 2 pi r. From here you are going to get r in terms of x. R is simply 28 minus x divided by 2 pi. So in order to find out the area of the circle, pi into r square is pi into 2 and 28 minus x by 2 pi whole square. So this is 28 minus x 2 pi whole square. When you square this, what do you get? And 1 pi will be cancelled. I'll just show you what when I'm going to show it to you, that will just deal with 1 pi. Now the complete area is simply the area of the circle plus area of the square. These two areas have to be combined, and this has to be said that this is minimum. So let me just combine these two and add these two. So the one will be x square by 16, because 4 4 is 16. 28 minus x whole square by 2 pi square, and pi is already there. So there is pi and 1 pi gets cancelled. So it will be simply 28 minus x square by 4 pi. 1 pi is there, and I told you that area of circle, if you see closely, there is 2 pi square in the denominator. 4 pi square will come and 1 pi will get cancelled. So ultimately what we got is x square by 16 plus 28 minus x whole square divided by 4 pi. Once we have this, we can just add them. Or the best thing is, rather than dealing with the square and adding it and forming an expression, better way is to actually differentiate it. So we are going to differentiate this expression, and this expression, single differentiation, the double differentiation, we have to prove that it is going to come as positive so that it can be minimum. So again, coming back to this expression which we were talking about, let us call it as z. You can call it as any variable which you want. But when we have taken x and y, the other will be z, of course. This is the trivial traditional thing we follow. Now I am differentiating, as I said, 4 pi will be in the denominator. X square is 2x, 2x by 16 is x by 2x by 16 is x by 8. 28 minus x, 2 into 28 minus x, and 28 minus x differentiation is negative. So we have just placed a negative in between. 4 pi is in the denominator. Now just equate it to 0. When we equate it to 0, this left hand side and right hand side, these two terms will go on left and right, and you have to just find out and rearrange it so that you get x. I hope you will be able to get the x from here, because this is not a very big task. The whole idea is to differentiate, equate it to 0, and try to find out the value of x, which will be the final answer. And you don't have to worry about the answer, because ultimately we have to show by the double differentiation that it is going to be minimum. So I'm just trying to find out the value of x that will be fed to y, because y has to be computed. That is going to be 28 minus the value which is formed here. So let me write the final value here. I hope you are able to understand these all concept. The only resolution after simplification, the final value we are going to get, x is equal to 112 divided by pi plus 4, and y can be computed by 28 minus x. 28 minus 112 by pi plus 4. That will be your y value. So this is how we get the x and y value. I hope this is quite clear to you. X and y value we have come across and we have found it. Now this x and y can be computed easily. The next step is to differentiate again. So I am differentiating it again. d2z by dx2. Already you know what we have got when we did the first differentiation. If you remember that thing, or if you are writing it right now, then you can just differentiate it, and you just have to prove that it is going to be minimum, because it is greater than 0. So just see that it is going to be greater than 0 or not. This is the first differentiation which already being completed. We are going to differentiate it again. 1 by 8 minus this 2 goes here, 1 by 2 pi. This is going to be negative, negative to negative, negative becomes positive. So we have 1 by 8 plus 1 by 2 pi, and evidently by visual inspection also this gives you greater than 0, that is positive, that is minimum only. So what was x? If you remember, it was 112 by pi plus 4. And in order to get y, it's simply 28 minus 112 by pi plus 4, as I indicated earlier also. And these are the final values which you can write. And this has come from all the discussion which we had when we started with circle and square area combination. So these are the length of the two pieces which will give you the combined area as a minimum for circle and square. So this is the whole solution or the reference which you can follow in order to solve this question. And there are certain languages which you need to write that are mandatory for examiner to know that you know this question, how to solve it. Next one is again almost equal to the similar question, previous one. A wire of length is 20 here. We have to cut it into two pieces, one into square and one into equilateral triangle. So there is a change from the previous question. Previously it was square and circle. This is square and equilateral triangle. And area of the square and triangle is to be minimum. So same on the line of the previous question, we will do the same thing. We have 1 as 20. If we take 1 as x, the other part will be 20 minus x. And same thing we have to do here also. X is the whole addition of the four sides. All the four sides are equal, so you can call it as 4 into side is equal to the perimeter. What is the perimeter? After all, this part is going to be bent in order to form a square. So when you make a square with this length, 4 into side is going to be equal to x. So side is simply equal to x by 4. That is 1/4 of x. That is a simple and very common sense discussion, that if 4 sides are being made or 4 parts have to be made equally of x, it will be x by 4. So area of this square will be x by 4 whole square, that is the side square. X square by 16 is the first part we have done. The second part is for triangle, which is the equilateral triangle. Now this 20 minus x is the whole length, and this whole length will be formed into this form of triangle, and this triangle will ultimately tell you that it's going to be the area of the equilateral triangle. Before that we have to find out the side. For finding out that side, we have to use the formula of the equilateral triangle perimeter. The perimeter, that means the 3 into side. All the sides of the equilateral triangle are equal. When all the sides of the equilateral triangle equal, that is 3 into side is equal to the 20 minus x. This area root 3 by 4 by sides into side square, we are going to use just now. But basically 3 into side of our equilateral triangle, of an equilateral triangle, is 20 minus x. So this side will give you 20x minus 3. 20 minus x divided by 3. Area of equilateral triangle is simply root 3 by 4 into side square. Root 3 by 4 into side is 20 minus x divided by 3. So you have 20 minus x divided by 3 whole square. Okay. Now the next part is we have to take them combined in a combined way. So when we combine the square and triangle, the z will be equal to area of the square plus area of the equilateral triangle. When we add this, x square by 16 plus root 3 by 4 and 20 minus x by 3 whole square. And rather than actually going for 20 minus x square as a minus b whole square, we will simply differentiate it here only. Differentiating here will be quite simpler, because x square by 16 will be 2x by 16, which will give you x by 8. Here in this case you have root 3 by 36. Let it be like this. 20 minus x square will be 2 into 20 minus x. Differentiation of 20 minus x will be negative 1. So this negative will come in between. This is not positive. Actually positive was already there. This will be negative in between. So we will get x by 8 minus 2 root 3 by 36 into 20 minus x. So there will be a negative in between. Now the next step is to, for minimum, maximum, or whichever way you want, it has to be equated to 0 in order to get the critical point, because that is the critical point, and that is the critical point which is the length of the wire here. So just equate this to 0. The left hand side and right hand side will come on the LHS and RHS, and from here you need to find out x. I hope you'll be able to find out the x, because this is simple simplification of the numbers which are given here. 2 into 18 is this, and 4, and this is going to be 9. So rather than, there is one more thing, root 3 is also there. So I'm computing it, but rather than computing, I will definitely leave it for you, because this kind of simple things I understand that you guys are quite well versed with, because you are in the 12th standard. Until 11th standard you have learned all these things, and you are well versed and well capable of solving these kind of simple expressions. So let me write the actual expression here. That expression is going to come like this. X is equal to, this is the x value and this is the final value. The y value will be 20 minus x. 20 minus of this value, that is 80 root 3 divided by 9 plus 4 root 3 is going to come as x, and 20 minus of this value will be the other value, which is y. These are the two parts. But we are not done here, because we need to differentiate it, and then we have to put it as negative or positive. We have to regard it as negative and positive. d2z by dx2. And the original expression, if you remember, was 2x divided by 16, and this is simply x by 8 minus 2 root 3 and 20 minus x divided by 36. So double differentiation will give you 1 by 8. This is going to be 20 minus x will give you negative. So I have already placed a plus here. 2 root 3, and this is going to be 36 in the denominator. Okay, so now this has no x, and you can just simply get the number, and number can be positive or negative. And this is positive because you can see all the numbers are positive. And once the positive number has been received, or we got the positive number, we can easily declare that this expression is actually going to give us the minimum value. This value indicates that the expression from where we started will actually give you the minimum value when we add the area of square and triangle. So x was 80 root 3 by 9 plus 4 root 3. When you subtract this from 20 minus 8 root 3 by 9 plus 4 root 3, y is going to be 180 divided by 9 plus 4 root 3. This is your x and y. Once you get this x and y, this is the final value. So this is the actual solution which is in front of you. It may take some time because root whenever root comes, there can be some mistakes that you can commit, but I hope that this is quite clear to you. Given the sum of the perimeters of a square and a circle, show that the sum of the areas is at least when or is least when one side of the square is equal to the diameter of the circle. So there are two shapes we are talking about here. One is the square, the other is the circle. If we take one side as x, every side will be x because it is a square. Square means all the sides have to be equal. So sum of the perimeters of a square, let us call it as k. Square perimeter is 4 into x, and the circumference of circle is, if you imagine or if you take x as the side of the square, r as the radius of the circle, it will be 2 pi r. From here we would like to find out x in terms of r. So when we take 4x, it will be k minus 2 pi r. When we have to divide it by 4, then x will be equal to k minus 2 pi r by 4. This is our first equation. Now the second thing comes is the areas of again square and the circle. The area of the square is side square, which is x square. The perimeters was 2 pi r for the circle, and the area is pi r square. When we take the sum of the area sum will be this x square plus pi r square, that is the area of the square plus the area of the circle. So let me write it here. I am taking x as k minus 2 pi r by 4. It should be taken in the next step, but I have done it here only. And pi r square was already there. As I told you, it is the area of the circle. And x square, we have taken k minus 2 pi r by 4 as the x. Now we are differentiating. Let us differentiate this equation. And I always tell you that differentiation is your responsibility, because differentiation we have already done whole chapter on that. Differentiation of this particular thing will be twice of k minus 2 pi r. And 4 4s are 16 because 4 is in the denominator. I'll just write 4 square. The differentiation of k minus 2 pi r is going to be k will be 0, 2 pi will be 1, and only negative r, I think negative 1 will come. 2 pi r will be the differentiation of pi r square. See, the area differentiation is circumference. Now we have this dA by dr, and this has to be equated to 0. Just need to rearrange, because as I said, k minus 2 pi r also has to be differentiated, and that is going to give you negative 1, because negative 2 pi actually, not negative 1, it's negative 2 pi. This is essential because we are going to equate, and this 2 pi is going to cancel, or pi can be cancelled out. So this k minus 2 pi r differentiation, k is 0, minus 2 pi r will give you minus 2 pi. You get a negative here, and we have a negative and a positive. So when we equate it to 0, one side you can write it as 2 into 2 pi into k minus 2 pi r. The other side it will be 2 pi r. Now you can just cancel these things out, and you can have a relationship of r with this k. Or you can say that there is a relationship which we want in order to tell that there can be certain critical points. This differentiation equal to 0 is all about finding out the critical point. But we have a relationship here. And when we have this relationship, this k is going to be, you can write it as k minus 2 pi r equals to 8r, because we are going to reuse this equation number 2. I'm again differentiating, that is the double differentiation I'm completing now. The double differentiation, I'm writing the final expression right now, because I am again reiterating, the differentiation is your responsibility, and I'm very confident that you'll be able to do it. Pi square by 2 plus 2 pi is positive. positive, this cannot be negative at all. It is positive. That means you are going to get the minimum value. And the question is also saying that at least is least. Least means minimum. That is why when we have an expression which is greater than 0, that signifies that we are talking about minimum, that is the least. Okay. Now k minus 2 pi r equals to 8r we have already got in the second equation. X was k minus 2 pi r by 4, and this k minus 2 pi r can directly be written as 8r. That is, the expression of 2 can be replaced in the expression of 1, that is k minus 2 pi r can be replaced by 8r, and this x is equal to 8r by 4. So 4 2s are 8, 2r you are going to get. X is equal to 2r, and twice of radius is nothing but the diameter. Diameter is from end to end line or a chord which passes through the center point. So if you remember, x was equal to 2r, the side of the square is equal to the diameter of the circle in order to get the least area that we have already shown here. So the side of the square is equal to the diameter of the circle. So whatever I explain, this is written here in English like language, and you have to do exactly like this. You can change the language, but the content remains the same. All these writing is very important, as I have been reiterating. Find the largest possible area of right angle triangle whose hypotenuse is 5 centimeter long. Now just take the right angle. This is a right angle triangle. In this right angle triangle, the right angle triangle means one angle has to be 90 degrees. Largest possible area, that means we are going to go for maximum. 5 centimeter, the distance is already given of, or the length of the hypotenuse is already given. Now you can take any value x or y, either way. You can take x as base, y as the height, or whichever way you want. But the thing is Pythagoras theorem that says you x square plus y square is equal to 5 square. So all this written material you have to write by yourself. X square plus y square equals to 5 square is our first logic. Y square you can take it as 25 minus x square. So you have y square equals to 25 minus x square under root. So when you have this under root, y equals to this one, plus minus I am not writing because the distance or the length cannot be negative. That's why I am not taking negative. Otherwise it will be coming as plus minus. I am purposefully ignoring the negative sign. Coming to the actual thing, which is the area. Area of the right angle triangle is simply half into base into altitude. If you have taken base as x or base as y, it's up to you. But it will remain as half into x into y. Now half into x is already there. The y has to be taken from here, 25 minus x square. Area is this one. Now we will differentiate it. When we differentiate this dA by dx, because there is only x as a variable on the right hand side. When we differentiate this, as I said, differentiation will take certain time, and I'm just trying to get your time less or take your less time. So I'm writing the final differentiation that will come. You can do it using the product rule, and this is the dA by dx. This is the differentiation. Now once you differentiate this, you have to place it as 0 in order to get the critical point that we have been doing in the previous exercises also. If you equate it to 0, the denominator is going to be 0, of course, because it is being multiplied cross. So you will get 25 equals to 2x square, that is x square equals to 25 by 2. X will be equal to plus minus under root 25 by 2, and that cannot be taken, negative cannot be taken. Under root 25 is 5 and 2 will be root 2. So you get x as 5 by root 2. This is x. How about y? Y is under root 25 minus x square. That is, you have to just place x square. X square is already there with us, which is 25 by 2. So y also comes as 25 by 2. 25 minus 25 by 2 is 25 by 2 only. When you take the under root of this will come exactly similar to the value of x, which is 5 by root 2. Y is 5 by root 2, x is 5 by root 2. These are the similar values. And there is one more thing which we need to check in order to complete this question, which is the largest possible area or the maximum. That can be done using the differentiation again. So I am doing the double differentiation here. And this double differentiation simply means 25 minus 2x square by twice of under root 25 minus x square, again differentiating this one. I am writing the final differentiation here, minus 75x plus 2x cube divided by 25 minus x square under root 25 minus x square. This is the whole double differentiation which you will get. And we need to check it when x is equal to 5 by under root 2. When x is equal to 5 by under root 2, this is going to get us less than 0. You can try it putting the value as 5 by root 2, and you will get a value which is less than 0. Less than 0 value indicates that we are talking about the maximum, which is the largest possible area in the question, in the context of this question. So that is how we got the value. We also indicated that it is going to be less than 0. Alright, and what are the values? Because x and y is not enough. We need to find out the area. Area is half into base into altitude. Base is already 5 by root 2 and the altitude is also 5 by root 2. Root 2 in the denominator will give you 2. 2 into 2 is 4. So in the denominator you will get 4. 5 5 so 25 is already there. So 25 by 4 cubic units. Square units, sorry. So it will be square units. So what did I tell? This is in front of you. The differentiation might take some time, but it's okay. I hope that you will be able to do it. So this is the English like solution which you have to follow. Next is two sides of a triangle have lengths A and B and the angle between them is theta. Two sides of a triangle have length A and B. So we have a triangle. You can make any triangle because there is no 90 degree, there is no equilateral triangle, there is no isosceles triangle. It's simply two sides A and B we have to take. And this A and B which we have taken, the angle between them is theta. What value of theta will maximize the area of the triangle? Area of the triangle is half into base into altitude in terms of an angle which is 90 degree. That is the right angled triangle. But for a normal triangle, when you have the two sides and the angle between them, it's simply half into base into altitude with an angle. What kind of angle? It's sine theta. Half into base into altitude. There is no base and altitude here. I'm just saying this two sides containing that angle, half into A into B, and the angle between them with the sine of it. Now I am differentiating it because A is taken as the area. I am differentiating it. Sine theta will be cos theta. Next step is to equate it to 0, that you already know. I am equating dA by d theta, that is the differentiation, as 0. When I equate it to 0, you will get A into B into cos theta divided by 2 as 0. A and B cannot be 0, 2 cannot be 0, cos theta has to be. So cos theta equal to 0, that means theta has to be pi by 2 because we are talking about a triangle and the angle of the triangle cannot go beyond that. Highest angle can be pi by 2. If it is an acute kind of angle, obtuse of course it will be higher. So we'll stick with this pi by 2 and I'm differentiating it again. Cos theta will be minus sine theta. And since this sine theta value is already known, and sine pi by 2, what is the value of sine pi by 2? Sine pi by 2 is 1 only. When you have sine pi by 2 as 1, you will get minus half into AB, that is negative AB by 2. When you get a negative value, that simply means that it is less than 0, which is showing that we are talking about the maximization of the area of the triangle. When we have the maximization, this has already been done. And the next thing is the actual finding out of the area. What is the final area? Half into A into B, that is the side holding the angle between them. What is the angle? Pi by 2, we have already known that. Half into A into B into sine pi by 2, which is 1. Area is AB by 2, A into B by 2, which is the maximum area of the. So what did I tell you? This is all what I explained, and this is how you are going to write. Especially the English sentences are the main key for your success, because if you explain it, you'll get it. A square piece of tin of a side 18 cm is to be made into a box without top by cutting a square from each corner and folding up the flaps to form a box. What should be the side of this square to be cut off so that the volume of the box is maximum? Find the maximum volume as well. Now just imagine this question. There is a sheet and the square sheet is having all the sides, because the square has this feature that all the sides has to be equal. Since all the sides are 18 and there are 4 corners, and those corners, all the corners will have square cut from it. This is square, this one square, this one square, and this one square. That means all these 4 square corners will be eliminated, will be cut, and then will form a box. And please remember, this box has no top, will have the base, but there will no top. So what do you get? These all portion will be eliminated, and finally a box will be formed, and that box will be of course a kind of a cube. Since we don't have the cover, that is the top, let us take one of the square and then try to formulate the side, because side will be less now. 18. What can you guess? What will be the side of the square when this 1x is eliminated? See, x is one side, x is another side. 18 is the whole length. We eliminated x and x from two sides, so it will be 18 minus x minus x minus x. So 18 minus 2x will be the length. What will be the breadth? Same logic. Because all the sides are 18. Again, on the breadth side also, the x side and x side is being eliminated. So again, the length will be 18 minus 2x and the breadth will also be 18 minus 2x. X from one side and x means corner and other x from the corner. So volume will be length into breadth into height, and that will be in cubic units. The length and breadth, of course, it is going to be 18 minus x, that is 18 minus 2x in case of breadth also and length also. So we have known the length and breadth. Now we have to talk about the height. What will be the height? Height is x. Because of course the portion cut is x and that will be folded, and once you fold the side of x, the height of the shape being formed, x will be the height. Now the next thing comes is the differentiation of this volume, that is x into 18 minus 2x whole square. And I can tell you that you can differentiate it by yourself because it is quite easier and we can just go ahead without wasting our time. I'm differentiating it using the product rule. First differentiation of second plus second differentiation of the first. That is what is the key. This has to be equated to 0, and once we equate to 0, there are certain things that are going to come up, and the way you are going to solve can be different from your friend because there are multiple ways to even simplify the equation being formed. What you are going to get here, rather than doing this, take 18 minus 2x terms on one side, take 18 minus 2x as common. Once you take 18 minus 2x common, you are left only with 18 minus 2x minus 4x, because 18 minus 2x we have already taken common. So you are going to get 18 minus 2x minus 4x, that is 18 minus 6x here. The best way, because this is all equated to 0. Remember, 18 minus 2x divided by say 2 and 18 minus 6x divided by 6. So actually you are dividing by 12 on both the sides, and remember I have not written equal to 0, but once you divide both sides by 12, it's going to be nothing changing on the right hand side, but on the left you are going to get 9 minus x, and what did I tell you? First part is divided by 2, the second part is divided by 6, so you are going to get 3 minus x. Alright, 3 minus x and 9 minus x, these are the two factors which will be formed. And once you get 9 minus x and 3 minus x, equating it to 0, we are going to give you the critical points. And these are the critical points, and in this case, in this question, they are the probable x, that is the side of the square that is to be cut from the corner of the original square. Now we have to check whether we can take x equals to 9 or x equals to 3, or both are possible. Can you imagine if you take x equals to 9, that is in between, can you form a box? No, it cannot be possible. Just think logically. But still we are going to check it because we have to explain the examiner why we need to eliminate x equals to 9 as the possibility. We can just take x equals to 3. So when we differentiated, double differentiated, when we differentiated and double differentiated, this is the double differentiation. I am placing x equals to 3 and x equals to 9 one time and other time. When we take x equals to 9, you are going to get certain value which is not going to give you the maximum value, because in order to get the maximum you need a negative number. But 6 minus 9 is negative 3, minus 24 is negative 24. You multiply it, you are going to get a positive value. Once you get the positive value, that just means that you are going to get a minimum volume. But we are not interested in the minimum volume. We are interested in the maximum volume. So we need to check for x equals to 3. If the square side which is being cut from the original square is x equals to 3, we get negative 24, and 6 minus 3 is 3. 3 into 24 is negative 72. When you get the negative 72, it signifies that negative value will give you the maximum volume. That is the maximum of whatever content you are actually wanted to see. When this maximum is there, we will eliminate or will ignore that part where we have checked x equals to 9, which was very logical that x equals to 9 cannot be the center point. It cannot be square. You will not get anything if you cut 9 side. Now volume is again x into 18 minus 2x whole square. X equals to 3, replace 18 minus 6 whole square. So it will be 12 square into 3. 144 into 3 is going to give you 432 centimeter cube. Why cube? Because this is the volume, not the area. So this is the whole discussion. Now the basic idea of solving this question is to imagine the original square, then the cutted or eliminated square. So this is the whole expression, and because if you make the expression, if you can actually create or maintain formation of this equation, all other things are just piece of cake for you. If you are on the 12th question, I hope you have already completed 11th question and you are quite known about this. A rectangular sheet of tin 45 cm by 24 cm is to be made into a box without top. In cutting off squares from each corners and folding up the flaps. Now this kind of question we have just completed. So it was square the previous time. Now we have the rectangle. Rectangle means the opposite side must be equal. That is the shape. Now this is the rectangular sheet. One side 45, the other side is 24. The question is that what should be the side of the square to be cut off so that the volume of the box is maximum possible. Maximum and minimum we'll just talk about in a bit. Now this square has to be cut. That means all the sides of the square are equal and these are say eliminated from the corners. So I'm making the square from the corners, and just imagine when you remove all these squares and try to flip these things up, the parts which are from where the squares are being cut. So when we fold them, there will be a box being formed. This box will not have any top, it will have a base, it will have 4 sides. So I'm just giving you an example what kind of box we are talking about. And don't worry about my diagram or writing. You know how well it is. So this is x. All of them are x. This is x. This one is x, x. Again x, x. So all the sides are x for the square. Length and breadth of these sides, when we remove the parts, because for every side there are 2 parts or 2 x's are being eliminated. For any side, if you see here in the diagram, then 45 minus x will be the side of the final board or the box that will be formed. Length will be 45 minus 2x. Similarly, 24 minus x, that means 24 minus 2x will be the breadth. How about the height? Because the side which is cut for the square is x, and when we flap it up to make a box, height will be x. Let us find out the volume now. Volume of any 3D or 3D object will always be in cubic units. Length into breadth into height. We will multiply these 3 and that will be indicating the volume of the final box that is being formed after all these formations. Now you need to multiply all these, or you can use the product rule, that is part product rule. I am differentiating now. So when we differentiate it, dv by dx, you can take 45 minus 2x and 24 minus 2x, then differentiate the x, that will be 1. Now keep 2 alive, that is without any changing, and whichever is remaining, differentiate it. Right now I am differentiating 45 minus 2x. Negative 2 will only remain. Same thing here, 45 minus 2x and x will remain as it is, but 24 minus 2x will be differentiated. And that differentiation is going to give you negative 2. All these have come. We have to equate this to 0. And because of the limitation of the time, I hope you'll be able to do the multiplication and equate it to 0. My intent is to give you an expression that is going to be formed finally. This expression, factorization, multiplication, differentiation, all these I have given for you. That means these are all your responsibility. Basic expression which is being formed is in front of you, and there will be factors x minus 18, x minus 5. If you multiply this, you are going to get the original expression. When you place it to 0, x will be 18 and x will be 5. 5 and 18 are 2 possible values, and we need to check for d2 v by dx2 double differentiation we are doing. After double differentiation, we have to check for 18 and 5. That is whether we are getting minimum or maximum, that is the volume, at 18 or at 5. So when we double differentiate, the expression will be 24x minus 276. Place x equals to 18 and x equals 5 in this equation which you just see of double differentiation. When we place 18, we are going to get certain values. Similarly, When we place x equals to 5, we are going to get certain value. And these values, first 18 will give you 156. 5 will give you minus 156. Now what do you see? We need maximum. That means we need a value of double differentiation as a negative. X equals to 5 is giving you negative. That means this is going to be kept, and x equals to 18 we are going to ignore. I hope you got the idea why we have taken x equals to 18 and eliminated or ignored x equals to 5. Sorry, x equals to 18 we have ignored. X equals to 5 is the final answer because they just wanted, the question is asking only about the dimension. When you have x equals to 5, length can be 45 minus 5 into 2 and breadth will be 24 minus 2 into 5. So this is the whole scenario. I'm not actually finding the volume because the question is not asking about that. They are only asking about the x. A tank with rectangular base and rectangular sides. And you have a rectangular base here and the sides are rectangular. Open at the top to the constructed so that its depth is 2 meter and volume is 8 meter cube. If a building of tank costs 70 per square meter for the base and rupees 45 per square meter for sides, it's meter. What is the cost of a least expensive tank? Now just imagine tank is always open from the top most of the time. In this case it is open from the top. The cost is also given. What will be the cost when we take the base in order to make it? What will be the cost of making the base and what will be the cost of making the sides? Just imagine the volume, how this formation of the shape will be concluded. Volume is 8 meter cube. Volume is always length into breadth into height. When you have a 3D shape, the volume becomes, because this is a kind of cuboid, LBH. It would have been cube if all the sides are equal. But here we have the rectangular base. I'm making a rectangular base here. And I'm just, see diagram, don't worry about the diagram. Worry about the concept which is emanating or coming out from this diagram. Now just imagine that we have L and B as the base, that is the length and breadth for the base. Height, what you see here is the height of the box. Length into breadth into height or depth, they both are same and they are given as 2 meter. So this is equivalent to 8 meter cube in the question. So we get a relationship between length and breadth which is 4. You can put length as 4 by B and breadth as 4 by L. These are two equations that you can use or that we are going to use when we form the equation. The second thing which comes, 70 square meter and all these 45 per square meter, that we are going to deal in the later part. But length into breadth equals to 4 is, please remember this is given in the meter cube. So L into B is 4. Now if building of tank costs 70 per square meter of the base, we need to find out what is the cost of least expensive tank. Least, what does it mean least? We need, after double differentiation, certain value which should point to positivity, that is it should be positive value. Now next thing is area. What is the area of the wall? There are two things, area of the 4 walls of the tank. So we have the opposite side, let us take, it will be B into H, so twice B into H. Now the opposite side of which I am indicating is length into height, so twice into length into height because they are two opposite say facing walls. 2 into H you can take common, so L plus B, this is going to be the final say area of the wall. I am just marking 4 walls here. Area of the wall will be 2 into height, length plus breadth. What will be the area of, there is one more thing which is the base. Now area of the base will be length into breadth, so you need to add, or we need to add length into breadth also. But since the costs are given differently, in this 2 into H, L plus B, H or height is already provided to us, which is depth, which is actually equal to 2 meter, 2 into 2 and length plus breadth. Now we cannot have length and breadth together. We need a differentiation. For that we need only one variable on the right hand side. That means we need to do some dA by dL or dA by dB. So total will be what? 2 into H plus L plus B, and as I said we have to add the base also. Once I explained about the walls, the side also has to be given, and you see that what is the length into breadth? It is already given as 4. We have already computed it. So I just placed 4 in place of L into B. So 2 into 2 h is 2. 2 into 2. Length plus breadth. In place of breadth, I am writing 4 by L. And this is 4 already, which is L into B. Now 4 you can take common. And 1 plus 4 by L. This is the total area. Base as well as the 4 sides which I am indicating right now. dA by dL. Because we need only one variable on the right hand side, so I'm differentiating with respect to L. L differentiation and 4 by L you already know. Equate it to 0 so that we get certain points which we discussed as the critical points in the previous discussions. We have 4 by L square, this is equal to 1. L square is equal to 4, L will be equal to plus minus 2. Now can you tell me why I should ignore the negative 2? Yes, because I know what you're thinking, because negative cannot be, how can the length be negative here? No, length can only be positive. What will be the breadth? It is 4 by L. 4 by 2 is 2. Breadth is 2. Length is 2. Height is 2. All the 3 dimensions in this particular example are 2, 2, 2. There is one more thing which is remaining, because we need to talk about the least expensive tank. We will double differentiate it. 4 into 1 minus 4 by L square has to be differentiated, and you are going to get certain value or certain expression, and that expression is this one. And this expression what you see here should be positive, because we need least expensive tank, and since we have got 32 by L cube, and that will always be positive. L cannot be negative, 32 cannot be negative, so this gives us the least expensive tank. Don't worry about the values, only worry about the sign whenever you are doing the double differentiation in maxima and minima. So now we have already got the dimensions. We have seen that you are going to get the least expensive tank. But what will be the cost? Cost has to be computed. So length is 2, breadth is 2, height is 2, and all these 2 we are going to employ these values in order to find out the cost of making this expensive tank. When you have all these as 2, cost is going to be what? Just multiply the area with the cost. So length into breadth is the cost, is the area of the base, and what will be the cost? Because 70 per square meter, 1 square meter is 70, so L into B square meter will be 70 into L into B. This is going to be 70 into 2 into 2, that is going to be 280. What is the cost of the walls? There are 4 walls which we talked about. If you remember, it was 2 into H, L plus B. H is 2, L is 2, B is 2, so 2 plus 2 is 4, 4 into 2 is 8, 8 is 16. We need to multiply this 16 with 45, and this will be the cost of the wall. And when you see here 8 into 9, 720 rupees, 720. We need to add both of these costs in order to get the total cost for whole tank. 280 plus 720 is going to give you 1000 rupees, 1000. That will be the total cost. I hope you have seen from where we started, how did we end, and main idea is to find out the expression. Single differentiation, double differentiation, you know very well. Cost is also important. A window is in the form of a rectangle, is surmounted by a semicircular opening. The total perimeter of the window is 10 meter. Find the dimension of the rectangular of the window to admit maximum light through the whole opening. Now the light is going to come from the whole shape which we are talking about. The base of the window is a rectangle, and there is a semicircular top. The rectangle is surmounted by the semicircular top. X is the base, Y is the height, or you can take in a swappable manner, you can take X as this one, Y as that one. And we are talking about the circle also. It is half circle, and the radius will be X by 2, because the opposite side of that rectangle we have taken as X. So the perimeter is all the distance you travel. If you start running from one point and just cover the whole line boundary and come back, that the distance you have covered is perimeter. Perimeter is already given as 10 meter. What is the perimeter? X plus y, and how about the semicircle? If 2 pi r is the whole circle perimeter, the perimeter of half of this thing, semicircular, will be pi r. So just write pi into r, but r is already x by 2. It is half of x which we have taken. This is what we have taken, means we have imagined or guessed. Now x plus 2y plus pi into x by 2 and this pi x by 2 plus x plus 2y is equal to 10, this will give you one expression. And we need y on left and other things on right so that we can actually differentiate. Whole idea of maxima and minima is to differentiate first. So we have an expression which is y equivalent to certain thing on the right. Total parameter we have talked about. Find the dimension of the rectangular or whichever window in order to admit the maximum light. Now this light is coming from total shape. Area will be what? Area will be the addition of two areas. One will be the rectangle, one will be the semicircle. So length into breadth is the area of the rectangle. And what is the area of the semicircle? Pi r square. When you divide it by 2, it will be pi r square by 2 because it is semicircle. And I am now writing x into y plus pi r square, but r is already known to us, x by 2, we have just known it. And in place of y, now replace this what we got. This is a pi into x square, x by 2 whole square, that I am writing first. And the second part, or the first term, I am writing later. X into y, I am writing later. Pi x square by this 2 to the 4. So this expression is coming from the total area. So just replace this pi by 2. It was pi by 2 actually. Pi by 2 whole r square. So you get this expression now. Next one will be a equals this expression. And I'm just writing it pi x square by 8 plus x by 2. This is the whole expression which needs to be differentiated. When we need a differentiation, I'm just writing so that it will be easier for you to differentiate. Next thing I'm writing is the differentiated expression. And since the differentiation you already know, I'm writing the final differentiated expression. And you are going to get pi x by 4 plus this. All this cancellation can be done, right? 10x by 10 by 2 minus 2x by 2, 1 plus pi by 2. We need to equate it to 0 in order to get the critical points or the value for which actually things are being talked about. That is, x is the basic value and y is the basic value here. And we have imagined that as x. Now place this in y because y was already the expression. So you will get y when you replace x as 20 by x plus 4. Y you are going to get as 10 by pi plus 4. You already have x and y from where we started. X and y we actually let us or anticipated. But now we have got the final value. Second thing will be the double differentiation of this expression. And let me tell you, the double differentiated value will be negative pi by 4 plus 4. Since it is negative, you are going to get the maximum value. And here maximum means maximum light coming from the whole opening of this particular shape. We already have the x and y, and the question is asking about the dimension of the rectangle. X and y is already known to us, so the question is done. Length and breadth, x and y is already known to us. And these are the expression we need to tell here in this question so that our question gets complete. And how you are going to write in your examination or in your classwork, let me just show it to you. So this is the whole scenario. All the discussion which I did is here. If you have any uncomfortability in making the differentiation and double differentiation, it is in front of you. But main reason of this question is not differentiation, double differentiation. They are just tools. Main thing is making the expression. That expression, if you make, all things becomes very easy. This question relates to the previous question in a way that this also has a rectangle as the base. Now the semicircular surmounted thing or the above thing, top thing has changed to equilateral triangle. Let us take one dimension as x and other as y. And since the base of the triangle is also x, let us start with the perimeter. Perimeter is the distance traveled on the boundary if you start and end at the same position. So we have x and y and also this x. Because it is equilateral triangle, all the sides are going to be equal. So perimeter will be x plus y, and since this is equilateral triangle, this also will be x and this also will be x. X, you can just start from any x or y. So I am just adding all the lines which are falling in the boundary. 3x plus 2y is already given as 12 meters because the perimeter is already given in the question. 3x plus 2y equals to 12. We get a relationship between x and y is all on the left, other things on the right. So x and y, we have got a relationship. Area is what? Now we need to find out the area because we are going to solve the largest area thing here, which is asked in the question. X into y is the area of the rectangle and root 3 by 4 into side square is the area of the equilateral triangle. Next thing is the differentiation, but before that we will replace y by x because we can differentiate only with respect to one variable. Now y is replaced by 12 minus 3x by 2, other things remains the same. Next is to differentiate now. As I said, a differentiated value I am going to write here, or the expression I am going to write here. You can just recheck it if you are doing together with me. 6 minus x, 3 minus root 3 by 2, and dA by dx is equal to 0, that we need to put so that we get some critical point. X you will get as 12 by 6 minus root 3. This is one of the dimension of the structure we are talking about. How about y? Y is simply 12 minus 3x by 2. Replace this x here. In this y expression, you are going to get 18 minus 6 root 3 by 6 minus root 3. Two dimension x and y already we got. Next will be d2a by dx2. Double differentiation we will do. The single differentiated expression has to be used for double differentiation. When you double differentiated it, you are going to get a value which has to be negative, and we got a value which is negative because root 3 is 1.732. 1.732 divided by 2 will be definitely value which is when added with negative 3 will give you a negative value. It is less than 0, so we get the largest area. And what will be the area? Area will be, because we are being asked only the dimension, we don't worry about the area because question is only asking about the dimension. But there are questions which will talk about the dimension, the area or the perimeter, etc. We can just multiply the x into y plus root 3 by 4 x square like that. Okay. So if you are doing it by yourself, all these English-like sentences has to be used abundantly. That is, these are the reference for you. You can try it, you can refer it, and whatever I have told you that has the logic which you can use. Show that the height of the cylinder of maximum volume that can be inscribed in a sphere of radius r is 2r by root 3. Now just imagine that you have a cylinder. It's a right circular cylinder and this goes inside the sphere. Imagine this as 3D because the sphere is 3D and the cylinder is also 3D inside. Now the radius of the sphere is already given. I am making the radius here and this is the radius, capital R, already given in the question. Now there will be a radius of the cylinder also. So let us imagine that the cylinder height and the radius, r is the radius and h is the height of the cylinder. Now this one is the radius I am talking about and this is small r that we have just imagined, and from here to here it's h, and it is quite evident from the diagram that this distance from the center to the top is simply h by 2. Now just concentrate on this triangle. This is a right angle triangle. We have HR as the base in the altitude, R as the hypotenuse. From here we can apply the Pythagoras theorem, and that Pythagoras theorem is going to give you as the hypotenuse square is equal to the base square plus the height square or the altitude square. Here we have r square equals to small r square plus h square by 4. Now we have got a relationship. You can have a relationship because R, capital R is already given. Small r and small h we have imagined by ourselves. So this one, h will give you twice of under root r square minus r square. One is the capital one, the other one is the small one. So volume will be, what will be the volume? Because we are talking about maximum volume, pi r square h. We call it as V. V is pi r square h. Now why have we done this? Why we are squaring it? Because this doesn't affect our final solution. Because whatever the value on the both sides is, if you square them, then also the things remain the same, and because of the next step what we are performing here. So this volume I have squared and I'm calling this v square. We cannot take v square every time. So this pi square r raised 4 h square, in place of h square you can replace this by 4 capital R square minus R square. So I'm replacing it right now. I've got it from the equation number 1 only. And next thing which comes from here, as we said that this V or whatever is on the right hand side, we square it, the things doesn't change. That is, the dz by dr is simply equal to dv by dr if we would have taken it earlier. So this is dz by dr. And when you differentiate it, and I know that differentiation is quite known to you, I'm writing the differentiation right now, and most of the things, better is to multiply this r raised 4 inside. Otherwise, you have to go for the product rule. Multiplying inside will simply ease your way of doing the differentiation. Now this is the differentiation value or differentiated value which I am talking about, and I'm going to differentiate and equate it to 0. So when you differentiate, you put it to 0. Now you will get the critical point, which is actually equal to the r what is being asked in the question, small r, capital R and h. Capital R is already given. So when you equate it and just take r cube outside, inside you have 4r square minus 6r to the power 2 equals to 0. R cube cannot be 0, the radius cannot be 0. So 4r square should be equal to 6r square. One is capital, one is r squared. Now you have a relationship between small r and capital R here. Small r square is 4 capital R square by 6. So this under root will give you twice r, and this is going to be under root 6. Let it be like that. But remember, what was r square? It was 4r square by 6 into small r square by 4, like that. Now we already got r equals to 2r by under root 6. Let us call it as equation number 2. We have already differentiated, equated it to 0. Next one is to find out the double differentiation. But before that, let us find out the height. The whole idea is to find out the height. In the question also height. So h is twice of under root capital R square minus small r square. Small r is already in terms of capital R, so just replace this 4r square by 6 as I indicated earlier. This height you are going to get as 2 capital R by under root 3. Now this actually solves the question, but the scenario here doesn't stop, because you have to show the examiner that this volume is actually maximum. So this d2z by dr square has to be done, and in any way you have to show that it is going to be negative, because negative corresponds to maximum value, positive corresponds to the minimum value. So when we differentiated, double differentiated, and now you have to do certain replacements that you will do, I am quite sure. And when you do all this, you are going to get certain value with certain sign. And we are not interested in the value or the expression. We are simply interested in the sign. So replace this small r by 2 capital R by the root 6. Final value is 4 pi r square minus 16 by r raised 4 by 3. Now these all are positive, these all are positive, negative is already there. So the result is a negative, which signifies or indicates that we are talking about the maximum volume with the height as 2 capital R by under root 3. So height already computed, but we have to strengthen our height computation by saying that this is the maximum volume. So this is the step-by-step discussion of what we have done right now. And once you have made this expression along with the diagram, because I showed it with the diagram, when you are aware of this expression, all things are a piece of cake for you. A rectangle is inscribed in a semicircle of radius small r with one of its sides on a diameter of semicircle. Find the dimension of the rectangle so that its area is maximum. Find also the area. Now this rectangle is inside the semicircle. Let us make the semicircle, and this is the semicircle. I am making a rectangle. Rectangle is that shape which have opposite sides equal, and square is the special form of rectangle where all sides are equal. We're talking about rectangle here. It is inside the semicircle. So this hole is twice r. So this rectangle could have been made like this because it is already given. The side is on the semicircle, and we need the maximum area. That is why we touch the corner to the semicircle, and that will give us a relationship. Let us say the x is the base and y is the height, or you can call it as x as the length, y is the breadth, which is popular when we deal with rectangle. Now we need the area to be maximum, but before that we need certain relationship, because small r is already given. x and y we have imagined by ourselves. So we need a proper relationship between this r and y and r, small r and the x and y which we have imagined. Okay, take this rectangle and this part which is the triangle which I actually trimmed out of it, and r is the radius which is actually the hypotenuse. Y and x by 2 are two supporting sides with 90-degree angle between them. Now you can apply the Pythagoras theorem here. That is, the r square is equal to y square by plus x by 2 whole square, which is x square by 4. So this equation is the key to solve this question. Now x square is this one. See, we are going to use it because x square we found out from this equation only. Second step is we need the area. We have to show that area is maximum. What is area? Area of a rectangle is the length into breadth. In this case, since we have imagined x and y, x into y is the area. Now when we deal with this x and y, we have to convert x into y or y into x. At least one should be in terms of r so that we can actually differentiate. It should be dA by dx or dA by dy. That kind of thing we are talking about. Now square both the sides. When you square both the sides, as I told you, squaring won't affect the result. So I've squared it just because we already have x square as 4 into r square minus y square. So in order to use it, I squared it and called the a square as z. It won't affect. Now y square and x square, because x square is already there, y square is there. So we have replaced x square by 4 into r square minus y square. This is z. Now second, or you can say the next step is placing this differentiation equals to 0. For that we need differentiation, that is we need to differentiate this. And once we want to differentiate it, what do we get? See, this is 8y r square minus 16y cube. And third step or the continuity step is to have a 0 on the right hand side. So 8y r square minus 16y cube is equal to 0. That means y into 8r square minus 16y square equals to 0. Y cannot be 0, so 8r square has to be equal to 16y square. From here we get y square is equal to 8r square by 16. So 8 to the 16 it goes. It's simply r by root 2. So we have the y value, and since we have the y value, we can use this y value, place it in the equation number 1 in order to get the value which is x, because x and y are guessed by us or let by us. So we need the proper value of them in terms of the given value, which is small r. So now I am replacing y as r by root 2 in the equation number 1 in order to get the value of x as well. Because the question is asking about the dimension, and dimension of the rectangle is x and y in terms of r is admissible only in this question. The fifth step which we are going to do is d2z by dy square. This is a completion step because the question is already being solved. But we need the double differentiation in order to show that the area which we are going to get will be maximum. And we need to find out the area also. So there will be next step also. But here the double differentiation, when we actually do it, and that is your responsibility, differentiation is quite easier for you. Now just replace this y by r by root 2 in the differentiation value which we got, and the final value which we get is a negative. This is the final value you will get when you double differentiate. So the negative value corresponds to maximum of whichever entity, in this case area, we have taken. So x is r root 2, y is r by root 2, and the sixth step and the final step is to find out the area. What is the area? Area is x into y. Multiply them, you can see visually root 2 gets cancelled. It's simply r into r, which is r square. So area of this shape, which is rectangle, is r square. So whichever things we have discussed is being given here, and you can follow this and write exactly similar to like this or in the terms which is written here. So you can take the reference also. Prove that the conical tent of given capacity will require the least amount of canvas when the height is under root 2 times the radius of the base. So simply we need to find out height prove h is equal to under root 2r. So this is a conical tent I am making. Just imagine you are wearing a hat on your birthday or eating an ice cream, cone ice cream. So this is an inverted cone right now. So this is the radius. From here to here we are saying that this is the height, and we need one more term here, which is the slant height, because the question is asking about the canvas, so we need the surface area. So first thing first is the expression, because everything comes with an expression. If you are able to find out the expression in the sentence type question or word questions, then the next thing can be done. Capacity only means the volume. Here capacity corresponds to volume. The surface area of cone is, you already know, pi into r into L. What is the L? L is the slant height, and this slant height is simply because this is a right circular cone, the L will be equal to under root h square plus r square. So pi into r into L, in place of L just replace it by the Pythagoras theorem value, which is under root r square plus h square. So I'm writing it directly. You already know it in your previous classes because we have already done mensuration quite a lot. Next thing comes in this question is the capacity. Capacity is the volume. Volume is 1 by 3 pi r square h when we take the cone. What is h? The h in terms of v, it's 3v by pi r square. Now we already have h. The surface area, because we need to tell about the least amount of canvas. So surface area has to be maximum or minimum. So surface area is pi into r, and under root r square plus h square, in place of h square replace it by 3v by pi r square. So this is the final result which we are getting when we replace it. If there is slight difference or mistake, I beg your pardon, but I'm writing because this is simply the replacement of the values we got. And the whole idea is that if you remember this surface area and the volume, you're going to get through it. So I'm making a relationship between the surface area. So this whole, I'll just change this v raised 6 because I don't think it will come. It will be square only. So I'll just replace it. But the next step has to be this s. Now this ds by dr has to be taken because the differentiation has to be done. The final differentiation value I'm writing here, and there will be some effort which you are going to put in for differentiating, and I'm writing the final value just for your reference. This is the final value when we differentiate it, and it will take because you have to follow either the product rule or the quotient rule. So there will be two terms here in the final differentiation. Once you differentiated it and just match it, okay, this v to the power 6 we'll just replace it by v square. It will not come. And when we equate it to 0, because the next step will be equating the differentiation to 0. When you equate it to 0, the final relationship will be 2 pi square r raised 6 is 9v raised. I am still skeptical about this v6. I'll just revisit this. See, all this will give you a relationship between your r and v. And v is already there with us. 1 by 3 pi r square is already there. In place of this v, I am replacing this v raised 6, which is a slight mistake which I committed. I'll make it as v square. V square is 1 by 3 pi r square h whole square. It will be 1 by 9 pi square r raised 4 h square. And this square, as I said, I'm replacing it. So we are going to get a relationship. All those simplification and cancellation you can really do and understand here. But the whole idea is to get, because we are interested in only the height should be equal to under root 2 times the radius of the base. So when we see here, there are cancellations which you see, and h is equal to under root 2 r will come. And this is the actually end of the question, I should say. But we have already proved it. But we are not going to stop here. You tell me why? Because in Maxima and Minima, you have to show that you are actually getting maximum minima, and that is only possible when we double differentiate it. So you need to do some more effort here. That is, the ds by dr has to be d2s by dr square. So the whole expression which I wrote, because I just changed this minus to equal. So d2s by dr square, and this is again an exercise for you. When you do it, it is going to come as positive. Okay, so because h equals to under root 2r is already done, this is just a completion step, which is the positive value should come so that least amount of canvas can be there. So h equals to under root 2r is where you are going to stop. And when we proved it, because we don't have to find any dimension of the area or anything. So this whole is the steps being followed here. And when we followed this diagram, because we started with the diagram, remember, and now we got this whole v raised 6 is a slight misprint that you can replace it by v square. So all these needs to be remembered from your earlier classes. Show that the cone of the greatest volume, which can be inscribed in a given sphere, has an altitude equals to 2/3 of the diameter of the sphere. Now the diagram will be something like this. There is a sphere. Imagine this is a 3D sphere, and inside this we are trying to place a cone whose volume is the greatest volume. So we'll show also that it will have the greatest or maximum volume. And this is the kind of scenario which is being created here. And the sphere we have to show, after all the computation and calculation, we have to show that the altitude equal to 2/3 of the diameter. So 2/3 into 2r, that is 2r, twice of radius is diameter. So 2/3 of the diameter is equal to the height of the cone. So we need a relationship between height, this radius, etc. So just try to imagine. First we have to say assume certain thing. So small h and small r, we are taking it as the dimension of cone. Height h, radius r. Now capital R is we are taking the radius of the sphere, capital R. And this h, r small and capital R sphere, let us point it out here. Let us assume that this is the center. Wherever you join any point of the circumference, it will be capital R. And this is the small r, which is the base of the circle of the cone. And if this is a cone, see, this is the r we are talking about, small one, and this is the small height we are talking about. Now next thing comes, because assumption has already been made. Now from the figure, what will be the height? See, let us mark the names if you want. That will be beneficial. But this portion, what is this portion? This portion, we can use the Pythagoras theorem, because this capital R is the hypotenuse, small r is the base, and this is capital R square minus r square. We don't have to name it. It is just the computation which has come from Pythagoras theorem, this height. And what about this one, this height? From this point to any point, because we are taking from the center, it is capital R. So height of the cone is capital R plus that small part which we got as under root capital R square minus small r square. So this one is the height, and this is the most important aspect of this question. If you are able to make this expression, other things are quite easier, because you know what to do now. Let us take this capital R on the left hand side and square it. H minus capital R whole square is equal to under root r square minus small r square. So we just squared it, and there will be a relationship, because h minus r whole square, we are going to square it. A square minus a square plus b square minus 2ab. This on the left, this on the right, r square minus r square, capital R square minus small r square, and this capital R square gets cancelled. So we'll have a relationship between the small h, r and rh. So r square can be represented, small r can be represented either in height, or height can either be represented in r. So first equation is being prepared now. Now what is the volume? Volume of a cone is 1/3 pi r square h, because we need to maximize and minimize this only. So pi r square h. Now this r square is coming from the first step. That is, in the first step we have computed already this r square, and I am replacing now this small r square with 2 into h into capital R minus small h whole square. So 2hr minus h square. So now you are ready with a relationship which is v. Next step is the differentiation of this function with respect to h. That's why we had all the h on the right hand side. So dv by dh will be pi by 3, 4hr minus 3h square. So we need to multiply this inside, and then we can differentiate. And next will be dv by dh equals to 0. That is, the differentiation when we place it against 0, we'll get the critical point. When we place this as 0, 4hr minus, this cancellation can be done. So you will have a relationship of h with capital R, And when you have the h with capital R, we can have a relationship of small r with the capital R. So you can write this h equals to 4 by 3 r. This 4r can be written as 2 into twice of capital R. This twice of capital R is nothing but the diameter. So this, we have already reached the answer now, because we wanted, or we were supposed to prove that the height, which is the altitude of the cone, is equal to 2/3 of the diameter. That has already been done. But the step to prove that actually the volume will be greatest, actually the volume will be highest, that can only be done when we have the double differentiation. So the next part is the differentiation already being done. Now that differentiated equation has to be used, and then double differentiation has to be done, d2v by dh2. So when we double differentiate it, it is pi by 3 4 capital R minus this expression, and this differentiation is already the second differentiation. And when we just place this small h by 4 capital R by 3, you are going to get a value which is negative. Don't worry about the value, worry about the sign. Now the negative sign means less than 0, that means the greatest volume. Now this step has to be completed by you, but finally is h equals to 4r by 3 we have proved by the main key, which is making the first expression. So the expression number 1 is the most important key here. Other things are quite known to you, and this is simply r square, but don't worry about this, we have already seen that, because sometimes you would like to find out small r also, but it is not required here. That's why we didn't do it. Prove that the semi-vertical angle of the right circular cone of a given volume and least curved surface is cot inverse under root 2. This question also needs a proper diagram and then the expression from the diagram. So volume is given, we need curved surface area, and that needs to be least. So I am making a cone, I am talking about this angle, and this is the theta we are talking about, this is the height, this is the radius, small r. Now what we have assumed, first let us know that the radius we have assumed to be small r, the height we assume to be h, small h, and this is the slant height, which is this one. So slant height is what? L square will be h square plus r square. So this volume, and volume we will take it as capital V and curved surface area as capital C. So the second part is this volume, which is 1 by 3 pi r square h. When we have this 1 by 3 pi r square h, it will be 3 into capital V, which is actually the volume. And so we have a relationship 3v by pi r square is equal to h. Now this slant height is simply under root h square plus r square. You already know about this because this is a right circular cone. So this L will be equal to h square plus r square. And since in the second part or second step we have already computed h, we'll replace h square by 3v square by pi square r to the power 4. R square is already there, and with under root, they are inside the root. So you will get a relationship or an expression for L. And what do you think? We need the least curved surface. So the curved surface is what? Just start thinking about that, because this is what I'm resolving, but I hope you'll be able to do this. But the key is here, the curved surface. What is the curved surface? If you remember, it is equal to pi into r into L. Pi is the 22 by 7, 3.14 constant number. R is the radius and L is the slant height, and that L is equals to under root h square plus r square. So C is pi into r into L, and this in place of L, try putting what we got in the third step. So once you have this C's, there will be certain calculation and computation, and once you are done with this, the next thing will be this DC or C dash, you can call it as dV by dr we are doing. Now you will ask why we are doing this dV by dr. See, this differentiation because we need the least curved surface. So dV by dr will not be the concept. Okay, we are actually we need to differentiate dC by dr. So just change this. This is not dV by dr. This is dC by dr. There is a slight change here. So dC by dr, I have written dV by dr, but assume it to be dC by dr. And that is simply pi into r into L. L will be what we got in the third step, because we already replaced what we got in the second step in the third step. So once you differentiate this, you are going to get this. This dC by dr you have to do. And this is equal to 0. dC by dr has to be 0 in order to get the least or the highest curved surface. When you equate it to 0, there is some certain relationship and the expression will be formed. What it can be? And that is equated to 0 because there are two parts which I showed here. And when we have a relationship, it will be v equals to under root 2 pi square r6 by 9. And in order to get r, see this r, same expression we can get r also. So this r will be 3v by pi root 2 to the power half. V is this one, r is this one. Because this we got when we placed dc by dr equals to 0. dc by dr was the differentiation. So when you actually simplify this under root 2 pi square r raised 6 by 9, you will eventually get pi r cube under root by 3. Now this v can be replaced here, and h is 3 into v by pi r square. We already have a v which we just resolved. So this is 3 pi by root 2, and since 3 into v is what? Pi r cube under root 2 by 3. Pi r square was already there in the denominator. So there will be certain calculation and computation, and this will give you r root 2. So the h and r are related by root 2. Now what is h by r? H by r is equal to root 2. Now if you take this as tan theta, this is perpendicular by base. R by h is tan theta. This is theta I am talking about. This is r, this is h. So when you take tan theta, it will be r by h. But we are interested in h by r. What is h by r? The opposite or the inversion of tan will be cot. R by h, if it is done as h by r, it will be cot theta. So cot theta is h by r, and this is a root 2. So theta is equal to cot inverse root 2. So this is what we were expecting and we got it. There is one more step. You have to double differentiate. D dash c by dr square, or d double dash c, you can say that c double dash has to be done. So these are the direct result, but all these differentiation has to be done by you. Main key is the making of expression. That is very important. Once you make the expression, this differentiation, equating it to 0, all these things are quite easy, and that can be completed by you in no time, which I can presume. An isosceles triangle of vertical angle 2 theta is inscribed in a circle of radius a. Show that the area of the triangle is maximum when theta is equal to pi by 6. Okay, now this is a 2D example. Don't assume it to be 3D. It's 2D. There is a circle and there is a triangle here. We are talking about a triangle. So two opposite sides of isosceles triangles are always equal, and I have marked it also. Let us assume this is the center. If you join this is going to be the radius, and radius always we assume it as a. You know, in this question we assume it is a, but we always do it as r. R has become a here, right? So we will take this angle as 2 theta. You will just know why we are taking this as 2 theta. We could have taken it as theta, but it is 2 theta. Now please assume that a chord, whatever angle it makes at the center, whatever angle it makes in the above part, it is twice in the ratio. That is, if the above this angle is 2 theta, by the property of the chord, this angle will be twice of 2 theta, that will be 4 theta. I hope you got why we got it. If the above angle is 30 degree, the center angle which the chord is making will be 4 theta. That is 30 into 2, 60 degree. So now mark it. This is A, this is B, this is D. Now see just one by one what we are doing. Triangle ABC, first one. ABC is an isosceles triangle. AB and AC are equal here. Let us say that it is AB is equal to AC. Now what is AD here? Because this is the height of that triangle, and the area of the triangle is half into base into altitude. So we need altitude. So AD is what? AO plus OD. You can write it as AO plus OD. Alright. What is AO? It's quite simple. From the center to any point on this circumference, if you draw a line, it will be radius. How about OD? Now make a separate triangle. This is 2 theta from the property of the chord making an angle at center and at the circumference. So this is 2 theta. So when you have this 2 theta, what will be base and hypotenuse? See, whenever we have this angle, I am making this angle. There are two triangles. 2 theta can be anywhere. So this is base, this is height. So always the base, when you have the angle, will be cos theta and the opposite will be sin theta. What I am trying to suggest here is AO, as I said, R and A, we will use it equivalently. A, but OD is going to be A cos theta and BD will be equal to A sin theta. You know what is the sin theta, cos theta and tan theta? The sin theta is perpendicular by hypotenuse. Cos theta is Pandit Badri Prasad Har Har Bol. That is what you have to remember, right? Now this we have a cos 2 theta because 2 theta was at the angle. So this will be a sin 2 theta. OD is a cos 2 theta. BD is a sin 2 theta because BD and DC are equal. Because we are dropping a perpendicular from O, a sin 2 theta, a sin 2 theta will be twice a sin theta. So BC length also we got. BC is BD plus DC, and since they are equal, BD is coming from the triangle OBD. I am again saying if theta is this one, if this is R, the opposite side, perpendicular side will be R sin theta, the base will be R cos theta. That's what we are using it here. So a sin 2 theta plus a sin 2 theta will be twice a sin 2 theta. Wherever I am writing theta, just assume that it is 2 theta. I'll just change it, but you got the idea. Okay, what is the area? Area of the triangle is half into base into altitude, half into base into height. What is base? Base is BC. What is height? It is AD. So this is ABC. Altitude is AD, it was AO plus OD, and we formed an equation out of it. Then BC, we formed a length out of it. So BC is BD plus DC, and they are both equal to A sin 2 theta. So half into base into altitude, that is half into A, twice of A sin theta into A 1 plus cos 2 theta. Okay. Now multiply these and try to form an equation, because ultimately you have to prove something, that theta is equal to pi by 6. So all these are 2 theta, as I told you that all these are 2 theta, because assuming 2 theta as angle BOC by itself will get 4 theta. Now this is a square sin 2 theta 1 plus cos 2 theta. Okay, now second thing will be you can try replacing things, or you can differentiate. You can just multiply inside, and once you multiply inside, or you can use the product rule also, but better way is to multiply inside. A square sin 2 theta plus a square cos 2 theta. So sin 2 theta into cos theta 2 theta is what? If you multiply it with 2, it will be, because 2 sin theta cos theta is sin 2 theta. So 2 sin 2 theta cos 2 theta will be sin 4 theta. But since we have multiplied 2 and divided by 2, there will be 2 also. Now this whole A has come in a form which we understand. And now there will be no product rule etc. Just differentiate this. So I am differentiating it right now, and differentiation is quite known to you. Now this 2a square you can take common. You will get cos 2 theta plus cos 4 theta. Now this cos 2 theta plus cos 4 theta has to be, or you can say dA by d theta has to be placed as 0. dA by d theta or a dash we have already computed. Now I am placing this 2a square cos 2 theta plus cos 4 theta equals to 0. This 2a square cannot be 0. So cos 2 theta plus cos 4 theta has to be 0. So cos 2 theta I am writing it here because of the lack of the space. Cos 2 theta equals to minus cos 4 theta. But you know negative can be taken inside if you place pi inside. That is minus cos 4 theta is cos pi minus 4 theta. It is cos pi minus 4 theta. So now you have cos on both the sides. You can just equate this theta with this 2 theta with pi minus 4 theta. Now this 4 theta comes here. It is 6 theta. 6 theta equals to pi. So theta is equal to pi by 6. And that was what expected from the question. Alright. So all these steps we have done just to get the theta as pi by 6. First you have to make the line length in terms of theta, and then the final step is d2a by d theta square. Okay, that you already know. You have to show that it has to come as negative, this particular value, and to prove that the triangle is having the maximum area. This step also has to be done. Okay, and you just put this theta equals to pi by 6, and then you can find out that it is actually less than equal to 0, which I am trying to show it here also. But I leave it to you for double differentiation. But the whole idea is to start the question, which I already, it is being started, and we have reached that equation, which was the prominent thing of making it. So this 2 theta and 4 theta, that's why we didn't end up handling theta by 2 and theta by 4. So this base and altitude is the most important aspect. Other things are known to you. When to put 0, when to have double differentiation. Prove that the least perimeter of an isosceles triangle in which a circle of radius r can be inscribed is 6 under root 3r. Now this is a triangle we are talking about. This is isosceles. Isosceles means the opposite side or two sides should be equal. Now if you take this ABC, these two sides are equal. So you have to mark it by yourself. That is, in triangle ABC, AB is equal to AC. This is the first thing. Now the second thing comes is because this is X and this is Y, because both sides are equal, two sides are equal. That's why we have taken as X. Now inside we have a circle and there are certain properties you must know. So when you join this is a median, because in center is there is a median, and since it is an isosceles triangle, that's why it is a median. Otherwise it would not have been. And the properties of isosceles triangle and the median, when you see that if we take these points D, E, F, which touches the inside of the triangle, so we have this second thing which comes, O is the center or the center of the circle, then this divides the median, the center of the circle or the point where the center of the circle is, a line joining the end of or a vertex of a triangle or isosceles triangle to the opposite side passing through that center will divide this line into 2:1. So if AO is 2R, OF is going to be R. That is 2:R. Relationship will be twice of R. Now let us take this one and this one. So I am taking this triangle, and since we are applying the Pythagoras theorem here, and since the both sides are isosceles, means the sides are equal, this will be 90 degree. Please remember, if it would not have been isosceles triangle, we wouldn't have got all these properties. This is just because this is an isosceles triangle. So the 2:1 and the perpendicular from A to BC or CB, this all comes like this. So I'm talking about this A, this is F, which is perpendicular, passing through the center also. B is here. So I'm taking AFB triangle. Now in this triangle, you can take the Pythagoras theorem. AB is X, FB is Y by 2, and AF is AO plus OF. AO is R, actually it's 2R, and OF from the center to the side of BCF, OF is R. So you have 2R and R. This is Y by 2, this is Y by 2. As I said, this is the property. If you have isosceles triangle, this goes Y by 2, half of it. Now we have X square equals to AO plus OF whole square plus Y by 2 whole square. Again, this is Y by 2, this is X, and from here to here, this, assume that there is a point O here. So OA will be 2R, OF will be R. So AO, as I said, it's 2R, OF is R. So it's combined weight is 3R. 3R whole square is 9R square. So let me write it as 3R square or 9R square you can write. And here you have Y by 2 whole square. So Y square by 4 you can assume. Okay. Now this is the first equation you have. Now next one is, which is the fourth step you can say, because we have got a relationship between X and Y which we have imagined. Now you just join these. What do you get? ADO. See, this AO is 2R, AD is X by 2. Similar logic as this FB was Y by 2. Similarly, AD will be X by 2 because it is perpendicular. Again, the center of the circle, we have dropped a line which is perpendicular to this. Or even if you imagine the other aspect, one is R, one is 2R, this one, and this is X by 2. This is D. So AD square equals to, you can take the triangle ADO, 2R whole square, which is the hypotenuse in this case, is equal to R square plus, what is this side AD? You can just write it as AD. Now tell me whether it will be X by 2 or not. I told you that it may be X by 2, but you have to tell me about that. So this AD square is 4R square minus R square, that is 3R square. So AD will be equal to under root 3R square, that is under root 3 into R. This is your AD. Okay. Now the next thing comes, there comes the property of the tangent. That is, you have this A, B, C, and this is the circle inside. This is your D, this is E, this is, and please remember, this is not an isosceles or triangle related or circle related question. This is basically a trigonometry and shape mensuration related problem, because there are so many things involved here. When we drop a perpendicular from one point to the two sides of a circle, or there is no side of the circle, but two end of the circle, they become equal. So CD equals to CF. From A if you drop, it's AD equal to AE. From B if you drop, it's BE equals to BF. So as I said, y by 2 can be there, but what do you think that it will be x by 2 or not? You have to tell me. Now what was AD? I just told you it was under root 3r. We just computed it. And this AD plus DC is what? Please remember, because the side equal are AC and AB. What do you think? Whether AD and DC will be x by 2? First thing is AD will be equal to root 3r. DC is what? DC, this one, DC and CF are equal. See, AD or DC will not be equal to x by 2. You know why? Because the sides which are equal are AC and AB. So x is equal to root 3r plus y by 2. Okay? From here we'll get a relationship y by 2 equals to x minus under root 3r. This is 2. What was 1? Just let me know what was 1. You have to replace that one thing in here. Or you can use this first expression and second expression. Because of the lack of the space, I actually erased everything. So this is 3r square plus y by 2 whole square equals to x square. This we already know. This we have already computed. Now this y by 2 equals to x minus root 3r. This 3r square, y by 2 is already there. So in place of y by 2, we can replace it by x minus under root 3r. This is whole square equals x square. Now open this. This is 9r square plus x square plus this is 3r square minus 2rx under root 3 equals to x square. X square you can cancel and there will be a relationship between r and x. So just by rearrangement, you will get certain relationship. And that relationship or that expression from on left and right, that is x equals to 6r by root 3. This side actually AC, or you can call it as AB also, because they both are equal. And from second equation, y by 2 is equal to 6r by root 3, and I'm writing this x as 6r by root 3 minus root 3r was already there. So y you got as 2 root 3 into r. Now x and y is already there. The thing which they are asking is perimeter. Double differentiation, because we haven't done single differentiation. How to do the double differentiation? That question comes in this question. But just for the sake of completion, we have to do this question. So P is equal to x plus y. So it's 2x plus y. So 2x is 6r by root 3. Y is 2 root 3r. So perimeter is going to be 12r by root 3 plus 2 root 3 by r, and when you combine them, you will get 6 root 3r. So perimeter is equals to 6 root 3r. Now the problem in this question which I faced, and you will also face if you are doing it by yourself, where we are going to do the differentiation. We haven't differentiated at all. If we haven't differentiated, we cannot go for the double differentiation. So double differentiation is mandatory for least and maximum. Next question is, find the dimension of the rectangle of perimeter 36 cm which will sweep out a volume as large as possible when revolved around one of its sides. Now this is your rectangle, and this is L, this is B. You can assume any variable. So length and breadth you have found out. Now you take one of the side and just revolve it. Once you revolve it, what are you going to get? You will get a right circular cylinder. This is your length. What I am trying to suggest here is, length and breadth are the dimension of the rectangle that we have assumed, and V is the volume we are assuming. And since this rectangle is from one side, the radius of the right circular cylinder will not be L by 2 actually. We are not taking a center line from the passing through the center of the rectangle and then revolving it. We are revolving it around one line which is B here, which is the breadth. So this is length, length and breadth. So the perimeter is 36, so 2L plus 2B is 36. L plus B is 36 by 2. 36 by 2 is 18. So we get a relationship between length and breadth. So you can have B equals to 18 minus L, or L equals to 18 minus B, whichever way you want, because we are going to differentiate it anyways. Volume is what? Pi r square h is the volume of the right circular cylinder. This is your L. So this is pi r square h, 18 minus b whole square into h. H is what? B. When we differentiate it, dV by dB we have to do. And you can do it by multiplying b inside, or 18 minus b whole square. You can open it. So when you open this and multiply it inside, so you will get certain differentiation here. So I am just saying that 18 minus b whole square has to be opened, multiplied by b and just differentiate it. So when you multiply this 18 minus b whole square into b, you will get this expression. But dv by db, when we differentiate it with respect to b, what are you going to get? This expression. Next one is, of course, dv by db has to be equal to 0. So 324 plus 3b square minus 72b equals to 0. You can take 3 common from here. When you take 3 common, you are going to get b square minus 24b plus 108 equals to 0. And you will get 2 factors here because 24 is 6 and 18. Because 6 into 18 is 108. So you will get b minus 6 minus 18, b minus 6 equals to 0. So b minus 18 into b minus 6 equals to 0. So b will be either 6 or 18. But we need to check for both of these because we need as large as possible. For that we need double differentiation. So the fourth thing we have to do here is d2v by db square. You already know dv by db. Now you are going to differentiate it. When you differentiate it, you will get an expression. And in that expression, you have to first put or replace b by 6. The other time you have to replace b by 18. After replacing 6 and 18, you will see whether it is going to give you a negative value or a positive value. Because as large as means you need to get a negative value. That is important here, negative value. So 324 minus 3b square minus 72b. When we differentiate this and differentiation, double differentiation, I am doing the double differentiation. 6b minus 72 will be the result, and pi will also be there, pi into 6b minus 72. So when b is equal to 6 is 36 minus 72, so you will get minus 36 pi. And since it is negative, what are you going to get? B equals to 18, because once you got negative, it's maximum. When you put b equals to 18, you are going to get 36 pi. So it's positive, so you will get minimum. We have to take only the value for which you are going to get the maximum thing or volume maximum. So I am taking b equals to 6. So L will be what? 18 minus 6, that is going to be 12. So length is 12 and breadth is 6. So length and breadth are these values, and which is the answer because the dimension is being sought after in this question. So the diagram you need to make, because most of the time people will think or students will think that normally we revolve it around the center line, but here it is not. You are revolving it around the breadth b, which we assume, or the height actually. You can call it as a height in this case. All other things remains the same, making expression, equating it to 0, all this. Show that the height of the cone of the maximum volume that can be ascribed in a sphere of radius 12 cm is 16 cm. Now this question we have already done. The values were not there, but this kind of question we have already done. So we'll directly deal with the expression we've got. Let me just remind you or make you recall that in a sphere, 3D sphere, there is a cone inside. So h and r and v, height, the radius and volume we have taken. These are the anticipated or guessed value, let value. H and R are these. Next one will be the volume. How about the volume? How are you going to compute the volume? First of all, if you see the center, I am joining with the circumference radius, capital R. So capital R is the radius of the sphere that we have assumed now. The first thing which we have written are the imagined variables of the cone. Okay. How about this height? See, let me just write it here. H equals to, from here to here it's capital R, from here to here it will be capital R square minus R square, because we are using the Pythagoras theorem. This whole height I am talking about, R plus under root R square minus R square. So this question already done, that's why I am just doing it quickly. So H equals to R plus under root R square minus R square. All the small and capital R are going on. So H minus R will be equal to under root R square minus R square. You can just square both sides. So you will get h square plus r square minus 2hr. Here you will get r square minus r square. You can cancel this capital R square here. So there will be a relationship between h, small r and capital R. So r square will be equal to 2hr or 2rh minus h square. The third is volume is 1 by 3 pi r square h. 1 by 3 pi r square, we will replace it by 2 h capital R minus h square. R square we can directly replace it here. You can also mark this as the equation 1, and you can just say in English that we are replacing equation 1 in equation 2. Equation 2 can be v equals to 1 by 3 pi r square. That is the way you need to put in ink paper. Now second thing will be, or fourth thing will be actually dv by dr. We are differentiating it now, and we have to put it as 0 also. So I am differentiating this expression now. Once I have differentiated it, pi by 3 and bracket 4hr minus 3h square, dv by dr equals to 0. When you place dv by dr equals to 0, again h equals to 4r by 3, that you already know. We have proved it as twice of r, that is 2/3 of diameter in previous question. Next thing will be d2v by dr square. So we differentiate it now, and we double differentiate it now. Second differentiation, when we double differentiate, you are going to get this expression 4r minus 3 to the 6h. So 4 minus 6h. Now you have to place h equals to 4 capital R by 3, and you need to find out whether you are going to get negative value or positive value. If you get negative, it's maximum. If you get positive, it's a minimum. So this is d2v by dr square, and already the values are given, because radius is 12 centimeter is known to us, 16 centimeter we have to compute. So now I am replacing this h by 4r by 3. You can just take this 4 outside, because we are more interested in the sign here. It's minus 3r by 3. You can just cancel this. It's minus 4 pi r by 3. So what do you get? It's negative, it's less than 0. So you are going to get the maximum value. And maximum volume is when h is equal to 4 capital R by 3. Now in the question, capital R is already given, which is 12 in this case. So h will be equal to 4 into 12 by 3. It's 16 centimeter, which is asked in the question also. So we have computed the height, which is 16 centimeter, for the radius of sphere, which is already 12 centimeter. So all this procedure is known to you, and we have actually recalled that question we have earlier completed with the actual numbers 12 and 16 here. So all this let, imagined value, and finally h equals to 4 r by 3, will replace r by 12 in order to get 16, which is the height. A closed cylinder has a volume of this one 2156 centimeter cube. What will be the radius of its base so that its total surface area is minimum? So you can make a closed cylinder. Closed cylinder means the lid are closed. Volume is equal to pi r square h. This is small r, this is h. And better is to always draw the diagram that gives, you see, one picture is equivalent to 1000 words. So r and h we have imagined. What will be the radius of the base? So r we need to find out. The volume of the question in the question is already given. So it's 2156. You can directly replace or equate this pi r square h with 2156. When you get h, it will be 2156 by pi r square. And let me tell you, you can just use pi equals to 22 by 7 in this question. We have to use this pi as 22 by 7. We cannot just write just pi. So when you just have this h equals to, I've replaced pi by 22 by 7, and this is what we got. What is the total surface area? Total surface area of any shape is the curved surface area plus the area of the base and the top. So pi r square h is there, and 2 pi r square above, pi r square in the of the base. So pi r square h plus 2 pi r square, this is the surface area. So 2 pi r, you can just write h as 686 by r square, and 2 pi r square is already there. And since we need the radius, we have to differentiate this s with respect to radius. After simplifying this expression, 4312 by r, and this again, as I said, pi has to be written as 22 by 7. So better way is always in this question particularly, most of the question we have not used pi, we have just kept pi as pi only. Here you have to actually take pi as 22 by 7, and you get this expression pi equals to s equals to 4312 by r plus 44 by 7. This is 44 by 7 r square. Now next thing is ds by dr. Differentiation we have to do, because minimum maximum can only be done like that. So it will be minus 4312 by r square. 1 by r differentiation is negative 1 by r square. And this r square will be 2r. So it will be twice of r into 44 by 7. Next thing is ds by dr equals to 0. You have to differentiate and then equate it to 0. Once you equate it to 0, so finally r what will come, because the question is quite clear and very evident, r will come as 7 cm. Now since this r is 7 cm, you have to do d2v by dr, d2s by dr. Double differentiation we have to do in order to find out negative and positive, because if the surface area has to be minimum, you have to get a value which is positive. We need positive value. So we'll get this one, 176 divided by 7. It is greater than 0, so we are getting the minimum value. Apart from this, there is not much use of d2s by dr square. So radius is 7 cm. That is the answer of this question. Radius is 7 cm. This is the procedure. So whatever we have discussed, this is here only. You can follow this and use it. Making a diagram is always beneficial. Show that the maximum volume of the sphere that can be inscribed in a sphere of radius 5√3 cm is 500 pi centimeter cube. Now just imagine a sphere that contains the maximum volume cylinder. So I am drawing a cylinder which is inside a sphere. Just imagine this is in 3D. They both are 3D shapes. Now when you join the center of this cylinder or center of the sphere with any corner or any circumference, you get the radius. So we are assuming cylinder as HR as the height and the radius, and V is the volumes. For sphere, we will take it as capital R. So we assume this to be capital R. Now from here to here, this is the height. For example, this is the height 10. So 5 will be above, 5 will be the lower part. So this above part will be h by 2. The lower part will be h by 2. That's how you will get the maximum volume. That is quite, evident. So now we have the cylinder here. In this cylinder, this is the center. This is hole is edge. So this is h by 2, h by 2. Now I am joining this center to one of the corner of the cylinder. This is the capital R and this is small r, and this one is h by 2. Now from this figure or this triangle, what do you get? Use the Pythagoras theorem. Capital R square is equal to small r square plus h by 2 whole square. So this second step is, or you can say first was the imagination step. We imagined or assumed everything. Second step, we tried to find out a relationship between all these assumed variables r, h, r and capital R. So we got r square equals to capital R square minus h square by 4. The third thing is the volume. Volume is what? Pi r square h. And from here, from first equation, we'll put the value in the second equation. So this is going to be capital R square minus h square by 4, pi r square into h. Now you can just multiply this h inside, you'll get r square h minus h cube by 4. This is capital V. Now next step will be to differentiate this. When we differentiate this, of course, we have radius as constant because it is already given in the question. It is 5√3. So this is going to be dv by dh, which is pi r square, and this is h cube is 3h square by 4. And then next step, which is the fifth one, is dv by dh equals to 0. Now this pi into r square minus 3h square by 4 is 0, and then we'll get a relationship between r and h. So r square will be 3h square by 4. R will be equal to 3 by under root 3 by 2 into h. From here you can get h equals to 2r by root 3. So there are two relationship which we are getting here. R is under root 3 by 2h. H is twice of r by under root 3. Let me write it here, and you can call it as next step. R is equal to root 3 h by 2. How about h? Just told you. You can also use this equation number 1 in order to get a relationship also, but you are going to end up with the same thing. So if you want to put this capital R here, there will be a relationship between h and r. Do we need it? We don't. Why? Because 5√3 is the capital R, so we need to keep this capital R along with us. Okay. Next one will be, the next step is, because the values are already being provided, 5√3 is there, 500 pi is there. So h can be written as twice of r by under root 3. This is you can call it as a third equation. H is twice of capital R by root 3. Next thing or next step will be d2v by dh square. The differentiated value has to be double differentiated. Now I am double differentiating it, keeping it to 0, placing it against 0. So I am differentiating r square will be 0 because it is a constant. You can see that 5√3 is already given. This 3h square by 4 is differentiated, and don't worry about the value. Just worry about the sign. It's going to be negative because all other components here, you will find it that they cannot be negative at all. So it's negative equation because negative sign is there. So 2r by root 3 you can write in place of h, and this you don't have to do that, because you know that it is negative, so you know that you're talking about maximum volume. So this is maximum volume, just the sign indicates whether you are going to get the maximum or the minimum. We started with V, differentiated it, equated it to 0, then we did the double differentiation and found the sign to be negative, that is indicating maximum. Next one is the actual question being asked, that is, you have this sphere as radius 5√3. You have to tell or show that the volume of the cylinder is going to be 500 pi. So pi r square which is there in this r square, because it's pi r square h, it's small r square, we need the capital R. So pi capital R square minus, in place of h, write 2r by √3, and then again h will come pi r square h, so you can just write this 2r by √3. Now all this computation by placing radius capital R as 5√3 is going to give you the volume as 500 pi. So I'm just computing it, but I know that this is quite self-evident, and just use this 5√3 in order to get the volume, and that is going to be 500 pi centimeter. Hence we proved it. Alright, so the whole steps is the diagram first. From diagram you get r square equals to capital R square minus h square by 4. That defines this question. If you are able to make this, that is the key. I'm again reiterating, the equation 1 is the most important aspect of this question. Differentiation, double differentiation, equating it to 0, putting the value of 5√3, it can be done by you. But all this has come from a diagram, and that diagram has actually given us this equation number 1, where we just placed 5√3 finally and got this 500 pi. Show that among all positive numbers x and y with x square plus y square equals to r square, the sum x y is largest when x equals to y equals to r√2. So this is r by √2 x and y is equal to r by root. Now what will be the first thing? First thing is x square plus y square is equal to r square. This is already given in the question. And x and y you have to tell that it's going to be r by √2. So we'll work with x plus y, because this is the equation which has to be shown as largest. But using the first equation, which is x square plus y square equals to r square, from here you will get y square equals to r square minus x square. So you can get value y equals to under root r square minus x square. This is the first equation you got. Second thing is this x plus y. Now you need to actually express that it is largest. But this is x plus y, you cannot write just like that. You have to equate it with some variable. Capital Z we have taken as the variable here. Now this x plus y, in place of y I am writing it as under root r square minus x square. So this dz by dx, I am now differentiating it, and since we are differentiating it with respect to x differentiation will be 1. This under root r square minus x square will be minus 2x divided by twice of under root r square minus x square. Next thing is equating this to 0. dz by dx has to be equated to 0. When you equate it to 0, this 1 will be equal to 2x by 2 under root x r square minus x square. 2 will get cancelled. X will be equal to under root r square minus x square, or you can write it as x square equals to r square minus x square, because both sides can be squared. In order to get rid of under root, you can just square it. So this 2x square becomes r square. So x square is equal to r square by 2. So x will be equal to r by √2. Now you see in the question it is asked that x and y should be equal to r by root, and we got it. But you have just got x, and for the sake of completion we are going to find out y also. Now in this equation 1 you can place y equals to under root r square minus r by √2 whole square. I am replacing now x by r by root. So this y again will be r by √2. So both the values of x and y gave us r divided by root of 2. Now the largest stuff has to be also done in this question. For that we will double differentiate. So 1 minus 2x divided by twice of under root r square minus x square has to be differentiated again. When you differentiate it again, you will get certain value. Don't worry about the value, worry about the the sign. So once you get the sign, that sign has to be negative, because the negative sign will signify that you are talking about largest value or the maximum value. And when you have the positive value, it is indicating you are going to get the otherwise values. Now d2z by dx square, again I am just double differentiating. All these are positives, only negative sign indicates that you are going to get the largest or the maximum value. So this is the another step, and r, x and y we already got, and that is similar to the question which is r by root. So first is using x square plus y square equals to r square, then differentiating x plus y, and then finally showing that it is actually maximum or largest. X equals to y equals to r by root 2. Determine the points of the curve, this one, x square equals to 4y, which are nearest to the point 0,5. Now you have to see it very carefully. There are 4 to 5 questions like this. This is the second one. Now the next one, third one. Now why I'm showing you all this? Because all these questions are exactly similar. So if you understand one of it, you will be able to use that logic in others as well. So there are 3 to 4 questions which are exactly similar. They have no change at all except the values. Somewhere you have x square equals to 4y, somewhere where you have x square equals to 2y, somewhere you have y square equals to 2x, somewhere you have y square equals to 4x. So determine the points on this curve which are nearest to the point 0 to 5. I know this curve x square equals to 4y, and I would like you to tell me whether it is a parabola or a hyperbola or any conic section. So I randomly drew a shape. Call it as the x square equals to 4y. Now there is a point 0 to 5, 0 and 5. Now this distance x from xy, let us say that you have a point in this curve xy. Now this distance from xy to 0 to 5 should be lowest, minimum or nearest. So x square equals to 4y. This xy is nearest to which one? 0, 5. So now what we are going to do? We will use this equation, try to find out the distance equation, and then go about it. So from x square equals to 4y, you can use this to get y equals to x square by 4. When we have y equals to x square by 4, we will find out the distance. Distance is between xy and 0 and 5. So y2 minus y1 whole square plus x2 minus x1 whole square. If the 2 points are x1, y1 and x1, y1 and x2, y2. So this is the equation of the distance. Distance is simply this one. You have to take the difference of the x and y coordinates, square them and add them and take the under root. Now you can just swap them in whichever way you want, but we have found out the distance as x minus 0 whole square plus y minus 5 whole square and add them and under root. Same thing I am doing it here. So now we have got an equation, and this equation, as I told you, that if we take some variable, we square it also, it doesn't affect our final result. So we will call it as d, but we need to get rid of the under root. So in order to get the under root eliminated, you can just square both sides. So this d will be d square. On the right, we are calling it on the left d square as z. On the right, this root will get eliminated, and this is going to be x square plus y minus 5 whole square. Now you have y equals to x square by 4. Remember equation number 1. This equation number 1, y equals to x square by 4, has to be replaced here. So it will be x square by 4 minus 5 whole square in place of y minus 5. Now after this, you can just expand this. X square by 4 minus 5 whole square. You get x square by 16 plus 5 is 25 minus twice into 5 into x square by 4. So finally dz by dx has to be computed. What do you think? It has to be dz by dy or dz by dx? Of course, when you have x on the right hand side, you are going to differentiate it with respect to x. Now I am differentiating it, and differentiation is quite clear to you, so you can just write the final result. I am doing it for you because this will not take much time, but sometimes the differentiation takes more than the question time. So that's why I generally give this task to you. I'm differentiating it now. Now x square will be 2x, x raised 4 by 16 is 4x raised x to cube by 16 and 25 will be 0. This is 5 by 2, x square will be 2x. Okay, now this one, 2x minus 5x is negative 3x. So you are going to get 4x cube by 16 minus 3x. And this will be dz by dx. What do you think will be the next step? Of course, this has to be placed against a 0 in order to get the critical points. So this differentiation has to be equated to 0. That just means 4x cube by 16 is equal to 3x. Now you can just cancel x. You will get a value of x here. Basically, x square is 3 into 16 by 4. So you will get the value of x. Again, 4 4 is 16. This is going to be 12. Under root of 12 is 4 into 3 is 12. 2 will come out, so it will be 2 root 3. So we got the value of x now. I'm just going to write it in a bit. But the points have to be computed. X is already known to us now. So this x square equals to 12 just means x will be equal to plus minus twice of root. And as I told you, the points or the coordinate points can be in any quadrant. So you have to take both plus and minus sign. So x2 has to be equal to plus minus twice of under root. Now this we are going to place in the equation number 1. So this equation number 1 is going to give you the value of y. Now your question will be, are we going to use positive or negative? So let me again reiterate that all these different quadrants will give you different value of x and y, negative and positive. So you cannot ignore the negative value. You have to take negative, positive both. So y becomes now, when you place it in x square by 4, either it is negative root 2 root 3 or plus 2 root 3, it won't affect. It will be 2 into 2 root 3 into root 3, that is 2 to the 4 into root 3. So 4 into 3 divided by 4, and this is going to be 3. So now you have x and y values. One more step is there, because you need to tell that this distance is a nearest. For that you have a d2z by dx2. Double differentiation of 4x cube by 16 minus 3x has to be done. So 4x cube by 16 minus 3x differentiation. Don't worry about the value. Worry about the sign, because the whole idea is finding out what is the sign, because the nearest is the minimum. For minimum you need a positive sign. All right, so you need a positive sign. So this is d2z by dx square, and when you place this x square as 2 root 3, you can just keep this value and find out the value. But again, you know what I'm going to tell. Don't worry about the value, worry about the sign, because the sign tells you whether it is nearest or the farthest. So I'll just write the value. These are simple calculations, and I hope that you are quite well versed and known to all this. So I'm just trying to tell you that this is definitely going to be the lowest. For that you need a positive. So you get a value 6, which indicates that d2z by dx2 is indeed giving you a positive value, showing that you're talking about the minimum or the nearest. So positive is minimum, positive is nearest. So the shortest distance and the longest distance. So nearest is shortest. You might be thinking I am reiterating and telling things again and again, but when you will just in subconscious, when I say you so many times, it will be fed into your subconscious. Even in your dream you will see, oh, nearest or lowest means positive, the highest or the maximum, you should get a negative in d2z by dx. So all these is self-explanatory, and again saying that next question which you see here and other questions, they follow the same routine, same process, same explanation. So I hope you don't have any problem if we just go through and pass by all these questions which have the same logic, only the numbers have been changed, only x and y has been changed, and that will not affect your knowledge which you have gathered in question number 28. Again the same thing, we have done this question with x square equals to 4y. This question has exchanged the value of x and y and 4 with 2, so the logic remains the same. So this question number 28, 29, 30, 31, 32 all are similar. Okay, and these are the solutions, and I strongly recommend that you solve this by yourself. Any problem, then refer to these solutions, otherwise not. Find the coordinates of the point on the parabola. This is the parabola equation, which is closest to the straight line y equals to 3x minus 3. Now let me make a parabola. Let it be any shape, because question can be parabola, hyperbola, it can be any conic section. But we need a line, and this particular parabola or any shape distance, and this distance has to be minimum. This distance has to be minimum. So the parabola equation and the line equation is already being provided to us. So let me tell you that a distance of a point from a line which has to be minimum. What is the formula for that? So xy is the point we are talking about, and this straight line. So what will be y if you take it as x? You can take it as xy, but since the parabola equation is already given, why not to use it? So if x is x, y will be what? Y will be x square plus 7x plus 2. So these are the x and y points for the beginning. Now distance will be what? See, this is x and y. I'm talking about x and y distance. So distance of a point from a line is, we replace ax plus by plus c. X and y is being replaced by the x and y, the point from which the distance has to be formed or calculated. Now this y equals to 3x minus 3 is of the form y equals to mx plus c. And we are going to formulate it in the form ax plus by plus c. And need to make maximum positives here. You'll see just now. So we need to rearrange this equation. Y equals to mx plus c. Also we have a formula for that. That distance of a line, that is y equals to mx plus c from x and y, that is also possible. But the better way is this ax plus by plus c. It goes with all the conic sections and other figures. So we have this x, in this ax plus by plus c, you have to replace x by what? X I have written in the first, that is the parabola, and y also the parabola. So I am multiplying this equation by negative, so that I need maximum positives. That will make our life easier. You'll just see now how it will be easier. So this a is negative 3, b is 1, and c is 3. Okay, so in the denominator, when we talk about the distance, it will be under root a square plus b square. I'm not writing the formula, just saying it, so you need to keep it in your mind. So we have a square plus b square, negative 3 whole square plus 1 square, a square plus b square. And now in the numerator it will be ax plus by plus c, and xy has to be taken as xy the coordinate points from where the distance is being sought. Okay, this is negative 3 is a, b is a 1, and c is 3. And in place of x I am writing x, and here ax plus b, y, so b is a 1 and y is of course x square plus 7x plus 2. How about c? C has to be written like that. C is 3. So just write 3 here. C again, x has to be kept here, y has to be kept here, and c is of course 3. So this is your distance. This is your s. You can call it as a distance. Now this ds by dx, call it as a distance s. You can call it as a d also. So I am now simplifying it and then differentiating it. So this denominator is of course 1 by under root 10. This differentiation, I am doing this differentiation. So it is minus 3 plus 2x plus 7. 7 minus 3 is 4. You are going to get 2x and plus 4. So numerator you have 2x plus 4. Denominator you have under root 10. Next step is what? Of course we have to equate it to 0 in order to get the critical points. So 2x plus 4 by under root 10 has to be equal to 0. Under root 10 cannot be 0. 2x plus 4 has to be 0. So this will give you x equals to negative 4 by 2. That counts to negative 2. Now we have already got x equals to minus 2. How about the point y? Let us find it here only. Then we'll go about the nearest and the maximum minimum. Here we have y equals to, I am just replacing x by negative 2 in the equation of parabola. So you'll get a y here, and that is the value minus 8 it will come. Minus 2 and minus 8. Negative 1, negative 2 and negative 8. These are the x and y points. Okay. Now you need not to stop here, because one of the important aspect, because we are talking about minima and maxima chapter. So this closest means we have to take d2s by dx square, that is double differentiation. And when we take this double differentiation, you are going to get what? See, under root 10 will remain like that. 2x plus 4 is there. This 4 is going to be 0 only. 2 by under root 10 will come. So 2 by root 10 is greater than 0. That signifies and indicates that when it is positive, we are talking about minimum. So this diagram is important and the distance equation is very important. So all those we discussed is here. Now find the point on the curve, this one, which is at the minimum distance from the point 1, 4. And if you recall, this question 28 we have discussed in detail. And after that 29, 30, 31, 4 questions were there. And they were similar to this one which we are talking about. So you can just take the notes here, or you can take the reference. The concept remains the same. Find the maximum slope of the curve, this one. So this slope has to be maximum. This is the catch of this question. This question seems to be pretty easy, very nice. But there is a simple catch. You'll just see now. The first one is the slope. What is slope? It is dy by dx, it is tan theta, and it is m. There are so many names and the ways we represent a slope. Y is already there with us. It is negative x cube plus 3x square plus 2x minus 27. dy by dx has to be computed. Then when we differentiate this, you are going to get negative 3x square plus 6x plus 2. But this dy by dx, are you going to equate it to 0? No. Because the catch is this dy by dx was minus 3x square plus 6x plus 2. But we are talking about slope. So this dy by dx is slope. So this variable which I have written here, which is m, is actual equation to start with. We are not starting with the y equals to negative x cube like that. Actually, we have to start with negative 3x square plus 6x plus 2. This is the slope. Now you have to differentiate this. Okay, you are differentiating the slope which is asked in the question. So we have this negative 6x plus 6, and when we equate it to 0, it will be equal to 1. So x is equal to 1 we got here. So first thing, is it clear to you now? We are not dealing with this original equation. We have to differentiate. That will come to slope, and then we will start our actual things. Now d2m by dx square, that is going to give you maximum or minimum. This x equals to 1 is already there with us. Y equals to what? If x is equal to 1, what will be y? Keep it in the original equation, because of course we have to start with the original equation. So when you replace x by 1 in the original equation, x is 1, y is negative 23. X and y are 1 and negative 23. But what about this? 1 minus 23, is it the answer? What do you think? See, we have to find out the maximum slope. And slope is dy by dx. And dy by dx is negative 3x square plus 6x plus 2. So we have to use not the original equation, but negative 3x square plus 6x plus 2. Here you have to place x equals to 1, and then we'll find out the value of m, which is the slope. Actual equation is this one, as I have been reiterating again and again. I'm taking 1 and keeping it in m equals to negative 3x square plus 6x plus 2. That is going to give us 5. This m is 5. So this 1 comma negative 23 is not the what we wanted. It's actually 5. 1 comma 5. You can call it, or you can say that slope is 5. Or now, next one is the only thing which you will learn from this is there are 2 steps sometimes you need to follow. And all other things remains the same. Just differentiate the equation and start with the negative 3x square plus 6x plus 2. Other things like differentiation, going it to 0, finding out this double differentiation, all this remains the same. The total cost of producing X radio sets per day is rupees this one. And the price per set at which they may be sold is this one. Find the daily output to maximum the total profit. Now when it comes to profit, you have to just return back to your earlier standards or classes. That is, the formula which we have learned is profit is the selling price minus the cost price. That means if you got something for 5 and sold it for say 7, the difference 2 is the profit. This is the profit. And this profit, selling price and cost price to be extracted from this question. Since there are X radio sets per day, the total cost of producing X radios per day is this one. X square by 4 plus 35X plus 25. So in order to get the selling point, we have to multiply X with this one. I'm so sorry. X into 50 minus X by 2, because it is the price set at which they are sold. Sold means selling. You are selling. So X has to be multiplied by 50 minus X by 2. That is going to give you the selling point. Alright. And the total cost of producing X set, which is the cost price, which is, you don't have to multiply anything with this. This is already given in the question. So X square by 4 plus 35X plus 25. This 35X plus 25 is our cost price. So multiplication of X with 50 minus X by 2 will give you selling price, and the original thing which is given X square by 4 and all those things are the cost price. Now just multiply and simplify. When you add all these, you are going to get, means it's simply the 50x minus 35x is 15x. This is going to be 1 by 2 plus 1 by 4. It's going to give you 6 by 8. That is 3 by 4. So you have 3 by 4 x square, and then you have 25. 3 by 4 x square and 25. Just write 25 here. This is your profit. Now we need to maximize or minimize the total profit. In this question, it has to be maximized. I'm just saying minimize because there may be question in your exam that may be calling for finding out the minimum profit. That is not what generally in real life it happens, but just for the sake of completion. I'm not differentiating now. We need to differentiate this. Once we differentiate it, we have to equate it to 0. Once we equate it to 0, that just means we are going to get the critical points, and critical point is X here. What is X here? X is 10. When you get X equals to 10, that is the final answer. So you need how many? 10 radio sets. But there is one more step. Can you guide me? What is the step? Double differentiation. You have to differentiate it again. When you differentiate it, it is going to be negative 3 by 2, which is negative, and this negative is indicating that we are talking about the maximum. So it's quite easy, but the only thing is if you can recall all these things which you have learned earlier, it will be pretty easy. So this question is exactly similar to what we have just done, and I generally, when the questions are similar, I just show you the reference so that you can go about it solving, because all the logic has been actually imparted in the previous question. But I'll still make the equation here. Profit is selling price minus cost price, and what is being bought, what price it is being sold, the difference is the profit. So X item at a price of 5 minus X by 100. So when you multiply these two, you are going to get the selling price. X into 5 minus X by 100. What is the cost price? It is X by 5 plus 500. This X by 5 plus 500 is going to be your cost price. Now this question is and this differentiation is quite easy. You can just differentiate, equate it to 0, you will get X. Try to show the examiner that D2, that is double differentiation, also you have done, and that is going to be negative, that is indicating the maximum profit. And any problem, just let me know, we can discuss this further. An open tank is constructed with a square base and a vertical side so as to contain a given quantity of water. Show that the expenses of lining with lead will be least if depth is made half of width. So depth is equal to width by 2 is what we need to get. And you are just going to witness the most beautiful drawing you have ever seen. I'm just drawing the open tank. I'm trying it to make it as beautiful as I can. Let's see how it goes. So this is the tank I'm making. Please remember, the base is a square. The base is a square. The tank is open from above. It is open. So you have 4 walls and the base to deal with. Okay. The height is h. You can call it as depth also. V will be the volume, and surface area, because the expense of lining of lead, that will come from surface area only. So these are all our let guess or imaginations. Volume is what? What is the volume? See, since it is open from one side, we have to just stick to the basics. Any shape, the area of the base into height is what is the volume. So this is the length, because this base is a square, all will be L. So volume is area of the base, which is L square. And how about the height? You can call it as a depth also. It is h. From this we get equation number 1, v by L square is h. Now we need the surface area. What is the surface area? Surface area is 4 walls plus the base. So we have this because there has to be something to be done here. That is the lining of the lid. Okay. So the base area will be what? L square, length into breadth. And because this is a square, it will be L square. So this is the base. Now there are 4 walls here. The 4 walls, one of the area will be h into L. So 4 walls are there. So 4 into h into L. So h into L you can take, but just multiply it by 4 because there are 4 you can say walls. So what did I tell you just now? Surface area is L square plus 4HL. Now this L square plus 4 into L, this h has to be replaced by v by L square. You can just cancel these two. Surface area is L square plus 4v by L. Next is ds by dl. Differentiation we are going to do. And with respect to L, so it will be 2L minus 4y by L square, because there is 1 by L. It is definitely going to give you a negative in between. Now this has to be equated to 0. Once we equate it to 0, you are going to get 2L is equal to 4v by L square. And there is a relationship which we are going to use it in later part. L cube is equal to twice of volume, 2v. This is, you can mark it as equation number 2 if you want. But L cube equals to 2v, we are going to just use it. What about the other thing? Depth has to be equal to half of width. In this case, we need to prove depth was h and width is L. So the depth, that is h, will be equal to L by 2. That is what we have to prove. Okay, I'll just go with that later, but we need to do the differentiation because we have to show also the least part. That is the whole idea of this chapter, maxima and minima. So it will be d2s by dl square is, I'm differentiating this equation, so it will be 2 plus 8v by L cube. Now in place of L cube, just put this 2v from equation number 2. So this is 8v by 2v, this is 4. So you will get 6. It is positive. Positive means least, minimum. This we have proved. Now we have to prove depth is equal to width by 2 also. So this height is v by L square from equation number 1. Now just employ equation number 2 or utilize it and then try to find out whether you are going to get the relationship which I just told you. That is depth h is equal to width by 2, L by 2. So h is v by L square. This v has L cube by 2 as one of the thing, or L cube is 2v, v is equal to L cube by 2. Just keep it here. So h equals to v is L cube by 2, L square is already there. This gets cancelled, so h is L by 2. This is what we need to prove. This is what we got. Okay. So just remember, h is the depth, width is the L. So all discussion is represented here in front of you. A box of constant volume C is to be twice as long as its width. The material on the top and the 4 sides cost 3 times as much per square meter as that in the bottom. What are the most economic dimensions? So length, breadth, height, this we have to find out. This is a box, and in this box the story is that let me tell you, there are some certain guessings here. Let us what we do. So we need the dimensions. Start with the length and the breadth and the height. Any cube or cuboid, this kind of. So we have a box. Second thing which is being said, and volume also we have to include because ultimately the volume is given as a C, which is already given in the question. Now in the first line, the box of constant volume C is to be twice as long as its width. So twice long, this width is breadth only, which we have taken. This is twice as long as its width, means length will be equal to twice of breadth, 2b. This is the equation number 1 and we are going to utilize it. Third thing is the volume. What is the volume? Length into breadth into height. Any cuboid, length into breadth into height, 3 dimensions we are talking about. So just write length into breadth into height. But we have a relationship between length and breadth which is from the question, given in the question. So in place of L, you can replace it by 2b. So length is 2b, b is already there, h is already there. So this volumes become 2b square h. This is volume. So we will have a relationship with h. H will be equal to volume, which is C, it is already given in the question, by 2b square. The material on the top and 4 sides cost 3 times as much per square meter as that in the bottom. Bottom we will take separately. The top and the 4 side we are going to take separately because the material on the top and 4 side has some relationship, thrice relationship with the bottom. And there are 2 separate things, okay, because there is a relationship being given, and I'll just tell you what is that 3 times. So what is the cost? We'll take them separately. So bottom we'll take first. Cost of the bottom. What is it? It's per square meter. K per meter square. Let us assume like this. It's not given. We are just assuming that it is K per meter square. And then the second thing will be 4 walls and the top. This is going to be taken separately. 1, 2, 3, 4. This is the side and this is the top. And this is going to be 3 times. This is 3 times being given. So this cost will be 3 times. So 3k you can call. It is 3 into k. Okay, this is only the relationship which is given in the question. Now total cost will be the total cost. You have to take the bottom and the the walls and the top together. So what will be the cost per meter square is k meter square. So in order to get the total is you take the area and multiply it. So k into LB is for the bottom, and 3k will be multiplied by what? 4w and top. 4 walls and top. And all these 4 walls are different. They are not same. Top is also different. So what is the top? This is length and this is going to be breadth. So the length into breadth is top. L into B. This is the top. Now we have to see the walls. 4 walls. One will be L into H. One will be actually opposite sides will be same. So L into H, and then will have this H into B. Okay, twice, and since they are opposite, they ought to be equal. Twice into L into B plus twice into this length, and the breadth is already we have got. So breadth into height, 2LB plus 2BH. Okay, and opposite sides twice, this opposite side twice. I hope you got the idea now. And this is 2LH plus 2BH plus LB. So 3K is per meter square. In order to get the whole cost, you have to multiply 3K with the area which we have found. 2LH plus 2BH plus LB. So we have 2 relationship prior to that. Length is twice of B, height is C by 2B square. So wherever you get L, replace it by 2B. Wherever you have H, replace it by C by 2B square. So that is L into B. So again, length and breadth we have relationship. H is having a relationship with B as well. So rather than, because these all are assumed things, L, length, breadth and height are assumed things. So this length we have replaced it by 2B. So it will be 2B into K into B. So 2KB square. How about this one? 3K. Inside this we have 2 into LH. Plus 2 into BH plus 2L into B. As I just suggested, that L has to be replaced by 2B and H has to be replaced by C by 2B square. So this is your final relationship, or you can say final equation. We still have this B. C is already given in the question, so we don't have to worry about that. It is a constant. B is what we have assumed. K is, you can assume that it is already in the question K, alright? Because K is what we assumed and 3K, that is what relationship we have made. This B is on the right. So the fifth thing will be, we call it as a T. We will differentiate it with respect to B or C or K. It will be B because L and B and H are the variables. Differentiation will be only with respect to the variables. So there will be certain cancellation. There will be certain simplification. And once you do it, you will get differentiated value as 4KB plus thrice of K minus 3C by B square plus 4B. This is the differentiation. And then we will equate it to 0. And you have to equate it to 0. From there you will get something. What you are going to get? I am equating it to 0 since you can just multiply inside and take this 3K into minus 3 into C by B square on one side and 4KB plus 3K into 4B on other side. because you are actually equating it. So 4kb plus 3k and multiply, just multiply, wait, minus 3c by b square. Here you will get 3k into 4b, so 12kb, 4 3 is 12, 12kb equal to 0. What I was suggesting, this negative has to be taken on one side, and 4kb plus 12kb is going to be 16kb, but this k is assumed by us, so let us just eliminate this k, divide everything by k. So you get 9c by b square equals to 16b, and just multiply it here. 16b cube is equal to 9c. 16b cube is equal to 9c. So there is a relationship between our c, which is given in the question, b what we have assumed. So there is a relationship now. Okay, so b cube becomes 9c by 16. You can call it as b equals to, you can take this cube as 1 by 3 power. b equals to 9c by 16, 1 by 3. Next one is d2t by db square. Double differentiation you can already do, because this is just double differentiation. And single differentiation and double differentiation, you are quite well versed. So I am writing the double differentiated value, and this is the double differentiated value. And you remember 1 and 2 equation, and the final thing which we got, b cube was equal to 9c by 16. In place of b cube, write 9c by 16. This goes up. You just have to check for the sign, and you can see that this sign is what? If you want economic dimension, that is the least, for that least means minimum. For that you need positive value. So whatever it comes, I am not actually worried about the content. I am more worried about the sign. It is greater than 0. Greater than 0, it's positive now. So this all happened. b is 9c by 16 to the power 1 by 3. And since from the equation 1 and 2, length was what? If you remember, it's twice of b. So 2 into 9c by 16 to the power 1 by 3. This is length. What was the height? Remember the height? The height is c by 2b square. So this is c by 2 into, just take this 1 by 3 as 2 by 3, because you are actually squaring it. It will be 2 by 3. And when this goes up, there will be certain relationship. Actually, you will get all the length, breadth and height, and you have to get this length, breadth and height in terms of c, which is given in the question. You cannot have anything which you have assumed. Always the answer should come with values which are given in the question. Okay, so this is what we got. So first time you must do this question. This is a different kind of question, not that typical, but still the variables are. The sum of the surface areas of a sphere and a cube is given. Show that when the sum of their volumes is least, the diameter of the sphere is equal to the edge of the cube. So we have a sphere and then we have a cube. So you will see the best cube you have ever seen. I am making it. And there are certain assumptions we are going to make. Please remember what is given, what is not given. No variable is given. So we have to assume it by ourselves. R is the radius of the sphere. X is the side or edge of the cube. I am not writing any let or imagine. This I have showed you in the diagram itself. Okay. S is what? Surface area. Surface area, this is 4 pi r square. What is the surface area here? It's 6 into edge square or side square, 6x square. So the surface area becomes 4 pi r square plus 6x square. You just add them. Now find out the x here, because as I said, there has to be certain relationship that is to be made, which we are going to utilize later. So s minus 4 pi r square by 6 to the power half or under root of this. The second thing is the volume. Sum of the volume, their volumes is least. I told you about the surface area. Let us talk about the volume. You can call it as V1, V2. V1 corresponds to sphere, V2 corresponds to the other figure. So volume is 4 by 3 pi r cube for the sphere. What is the volume of the cube? It's just x cube. Why? Because length into breadth into height cube, that's what we do. So this L into B into H, x cube. Volume will be what? You can just add these two, 4 by 3 pi r cube and plus x cube. And this x was already computed by us, 4 by 3 pi r cube. This whole, I am keeping it here or replacing it here. s minus 4 pi r square divided by 6 to the power, because half was already there and this is 3. So 3 by 2 will come. Now we have to show that the sum of their volumes is least. So we need to differentiate it now. We have a single variable on the right hand side. We can differentiate with respect to it. So this dv by dr, what we need. dv by dr is the differentiation. So this is 4 pi r square. Volume differentiation always will be the surface area. This is what we have learned. And there will be this 3 by 2 will come. There will be some certain cancellation and simplification. So I am writing the direct value. It is 2 pi r into s minus 4 pi r square by 6. 3 by 2 minus 1 will be half. So it will be root. You can write it as half. This is dv by dr. The next thing is to equate it to 0. That is dv by dr is equal to 0. When you equate this, 4 pi r square will be equal to 2 pi r into s minus 4 pi r square by 6 to the power half, or root of that. So I am doing it here only. Now if you remember, what is s minus 4 pi r square by 6 to the power half? It was x only from the equation number 1. Got it? So you can just write in this s minus 4 pi r square by 6 to the power half is x. There will be certain cancellations. X is equal to twice of r. This is one of the things we got. X is equal to twice of r. And we have used or employed this equation number 1. Now this work which I am giving it to you, this is your responsibility. That is the double differentiation, d to v by dr square. And please remember the volume, this d to v by dr square should be positive or negative. Tell me, because you are talking about least. When you are talking about least, this will come for pi r square plus 2 by 3 pi square r, and it is greater than 0. When it is greater than 0, you get the minimum, least. X equals to twice of r. Twice of r is what? Diameter. So the question is saying the diameter of the sphere is equal to the edge of the cube. So this edge is x, diameter is d. So this is the relationship which we got after completing all these things. So edge will be equal to the diameter. We have proved it. Okay. Differentiation, double differentiation, please, I request, kindly perform it by yourself. I can give you the reference, but here all idea is to show the maxima and minima. Even the question has a lot of stuff in it. I mean, a lot of geography and volume and surface area, all this will come. So edge, which is side, is equal to the diameter that we needed to prove, and we proved it. Diameter equal to side. A given quantity of metal is to be cast into half cylinder with a rectangular base and the semicircular ends. Show that in order that the total surface area may be minimum, the ratio of the length of the cylinder to the diameter of its semicircular ends is pi by pi plus 2. Now just assume there is cylinder, and this cylinder is, assume that it is cut into half. Volume is what? What is the volume of the cylinder? Pi r square h, but we are going to make it half. You just see that it is going to be half. What is the surface area? It's 2 pi r h, and that is also going to be changed, because we are not going to use it wholly. The question is saying that it is not the cylinder. There will be a half cut, and just put it down on a table so that the cut part, which is the rectangular part, is on the table, and the semicircular part is what you will see, because the base will be on the table. So this is what the a vague diagram. Now you have to show that the diameter and length are related with some certain ratio. So just take the length. L, I am taking L, which is the height here. H and L we are using interchangeably, and diameter is this, because this is radius, so you have to take you would have taken radius, but don't take it, because the question is discussing about diameter only. That is why we have taken capital D, which is the diameter. Diameter is always equal to twice of radius, but don't worry about that. Use D. In many literature you will see they have taken radius, but since the question is only saying about diameter, we are taking it. What is the volume? Half of it. Once you cut it half, it will be pi r square h by 2. And this h you are going to take it as, what is h? L. What is r? R is d by 2. Radius is half of the diameter, or diameter is twice of the radius. So volume becomes half pi into L into d by 2 whole square. D square by 4 you will write because it is square of d by 2. Volume, what do you get? Volume is, I am just resolving it now. 8 will be in the denominator, pi into L into d square will be in the numerator, pi into d square into L. This is your first equation. You will find L from here. L is 8 into V volume by pi d square. This is your first one or second one. What is the total surface area? What is the total surface area? There will be three things here. First is these two semicircular part. These two circular part I am saying. See, this is half of it. Pi r square is for circle. Half of the circle is pi r square by 2. 2 into pi r square it is. 2 into pi r square by 2. So basically there are two semicircle. It will form a pi r square only. In place of r, write d by 2. So first is pi d square by 2 for both the surfaces. How about the rectangle? It's d into L. L into d. Length into breadth. What is length? Length. What is breadth? D, which is the diameter. And in place of L, just write this 8V by pi d square. I am multiplying it now. So d into 8V by pi. This one d will cancel, pi d square. So 8V by pi d. Third thing will be what? This curved. Just imagine that we are talking about the curved surface. And this total curved surface was what? 2 pi rh. We are talking about half of it. It's pi rh, pi rl, because of course h we have taken as L. How about L, as we have replaced it in the previous also, we will replace it by 8V by pi d square. So now the third part, because as I said there are three different parts of this whole thing. So 8V by 2D. Next thing is we are assuming this total surface area as S ds by dd. On the right we have V as the volume, which is already there, but d is the variable. So we are differentiating it and the differentiated value is in front of you. Pi d by 2 minus 8V by pi d square minus 8V by 2d square. For minimum maximum you have to equate it to 0. Once you equate it to 0, all the negative things take on the, means negative, not negative things, it's negative sign. Take it on the right, others on the left. So there will be a relationship between V and D. So D square is going to be 16V by pi, 1 by pi plus 1 by 2, half plus pi. So I am just clearing it. So just remember what we have done already. ds by dd equals to 0. And this d cube is 16V by pi, 1 by pi plus 1 by 2. This already you know. Next one is d2s by dd square. Again, this responsibility lies with you. This is a double differentiation. So you will get pi by 2 plus pi, which is actually greater than 0. What is there? Just revisit. L was 8V by pi d square. What we will do? Because d cube is already there with us. D cube. And we will replace this V by this relationship. That is, V will be d cube pi by 16 into, in the denominator itself, it will be 1 by pi plus 1 by 2. Okay, pi into d cube, as I am saying, just capital V will replace by this equation which I am showing on the top. This pi into d cube by 16, this goes as 1 by pi plus 1 by 2 will be 2 plus pi by 2 pi. So this d, 1d will remain, 8 to the 16. This goes up, as I said, it will be 2 plus pi by 2 pi. So 2 pi will go up, 2 plus pi or pi by plus 2 will remain in the denominator. So you will get certain cancellation. Pi into 2 pi divided by pi into this 2 plus pi. You can just cancel these two, 2 you can cancel. So it will be pi by 2 plus pi. So L is d into pi by pi plus 2. So L is to d, L divided by d is pi by pi plus 2. So do you think we have solved it? Yes, we have proved it. Because the length to the diameter ratio should be equal to pi by pi plus 2, which we have got by all these computation and calculation. So this whole is the solution, or you can say the reference if you are doing it by yourself. Most of the time people use radius, they don't deal with diameter because the question is specifically asking about diameter, so we didn't go with the R. The strength of a beam varies as the product of its breadth and the square of its depth. Find the dimension of the strongest beam which can be cut from a circular log of radius A. Remember, this radius A is already given. This is the circular log. Just assume that you have cut a part of a tree and that is the circular log. Now we have cut a portion, a regular portion from this or chiseled it in the form of a cuboid. So there will be length, there will be breadth, there will be height. Now this part, now I'm talking about this shape. I'm separating it. Okay, so this is being separated, right? So what do you see? This is one of the part or the end part, you can see. Let us assume certain thing. We need to assume certain thing. Breadth is B, height is H, strength we don't know what it is, but we will keep it as capital S. What is this from here to here? It's A and A. Radius is A, so this whole will be, or the diagonal length will be twice of A. This is B and this is height, breadth and height. This is breadth, this is height, and the diagonal, which is actually the part which I have shown here, is A, and A, twice of A. Now what do you think about using the 90-degree angle and consequently the Pythagoras theorem? So you have the hypotenuse as A plus A twice A, you have the perpendicular as H and the base as B. So when you square it to A square, actually it is twice of A whole square, equals B square plus H square. 4A square is B square plus H square. When we have this 4A square equals to B square plus H square will be 4A square minus B square. Now the second equation you are going to get from here, we have already got it. So you can just write it like this. 4A square minus B square is equal to H square. This is we are going to use and employ. Now the strength of the beam varies. Now please remember, there is a proportionality thing. If I say P is proportional to Q, two different entities, if you remove this proportional sign, you have to put a K, some constant or C constant. So this strength varies, that it is proportional to the base, and of course the height is depth is height. So it's breadth into square of the depth. So it will be breadth into height square, B into H square. When you replace this in proportionality sign, it will be some K constant. So S will be equal to K into BH square. S is K into BH square. Now in place of H square, replace it by 4A square minus B square. 4A square minus B square. Now we will differentiate it. ds by dp. Once you differentiate it, what are you going to get? Just multiply this kb inside and then you will feel. K cannot be, should not be multiplied because it's constant only. 4a is a square into b minus b cube. That has to be differentiated. You will get 4a square minus 3b square. So ds by db has to be equal to 0. 4a square will be equal to 3b square. And there will be a relationship between these two, a and b. B is what we have assumed. A is what is given in the question. So b we get under root 4 a square by 3. It will be twice a by root 3. This is your b. Now just take this and put it in equation number 1. This b equals to twice a by root 3 has to be taken and kept in equation number 2. And you need for the strongest beam. So minimum, maximum has to be also done. Okay, double differentiation is your responsibility. Just double differentiate and try to prove what is suggested in the question. Next one is d2s by db. So I'll just give you a hint. It will be minus 6k into b. It is going to get negative. Negative means maximum. Maximum is strongest. Strongest is maximum. Maximum is negative. All these are interchangeable. So you can call it any of these things. The thing is negative has come. So b is twice a by root 3. Use the equation number 1 in order to get this a. So 4a square minus b square is of course 2a. You can write it as b square as 4a square by 3 also. So you will get h. H will be what? 2 root 2 by this root 3 into a. So h and b, height and breadth, are the dimension of the strongest beam which can be cut from a circular log of radius a. So please draw the diagram and then try to suggest all these things and compute all these things. Okay, I hope that this question is clear to you. A straight line is drawn through a given point. This P1, 4 determine the least value of the sum of the intercepts on the coordinate axis. Now, if you understand this diagram, it will be very easy for you to solve this question. So we are making the coordinate axis. This is your x, this is your y. And the question is asking that a straight line is being drawn from 1, 4. So x is 1 and y is 4. So Roughly we are trying to draw a line, and that line is going to cut or intersect the x and y axis. The length of the x axis from 0 0 till where it cuts is x intercept. Similar, from 0 0 till it cuts the y axis, the distance is y intercept. So the question is all around this x intercept and y intercept. Now this is a line which is passing through 1, 4. We are going to make an equation of a line passing through 1, 4. What is the line of the straight line equation? Y minus y1 equals to mx minus x1. Line is passing through x1, y1 having a slope m. What is x1, y1? We already have it. x1 is 1 and this y1 is 4. From where did we get it? It's already given in the question. So we are putting it in the equation. So y1 is 4 and x1 is 1. X-intercept, this is basically a distance, from 0, 0 to, we know that on x-axis y is 0, on y-axis x is 0. So I am just placing 0 wherever it will be, and the next thing will be, for y-intercept x has to be kept 0, and for x-intercept y has to be equated to 0. So that's what we are doing right now. Y is equal to 0. So this is negative 4 equals mx minus 1. Just put y equals to 0. So you have a relationship of x and m. Call it as certain number of equation, means give it a number. Next thing is x equals to 0, because now x equals to 0, we are trying to find out the y-intercept. Now this content is actually placed there. I'm not writing it because of the lack of the space. But this whatever is coming here, they are basically the coordinates of x and y. Y will be equal to what value in terms of m? We have placed x equals to 0, that is we are talking about the y-intercept. X-intercept is m minus 4 by m, that we already got. Okay, y-intercept is also this one, negative m plus 4. Just imagine that where I'm pointing, it is being placed there. Now the intercept is already with us. Next part of the question is, determine the least value of the sum of the intercepts on the coordinate axis. So this is x-intercept, this is y-intercept. So the question is all about the addition of the x-intercept and the y-intercept. So let us call it as S. X plus y, these both are intercept. And the values are known to us. One is m minus 4 by m. The other one is a negative m plus 4, or you can call it as 4 minus m. Now, this is S. Now the third one, we need to also establish that it is least. For that we need to differentiate. I am differentiating it right now. And when we differentiate it, because actually what differentiation of what content? Addition of x-intercept and y-intercept. So when we differentiate this, you have m minus 4 by m plus 4 minus m, or m minus m plus 4. So when we differentiate this, m by m can be 1, 4 by m minus 4 minus m plus 4. So just differentiate it, and you know already that differentiation is. I have not differentiated it yet. It is actually S. I'm just saying that you need to differentiate it now. Once you differentiate it, you are going to get certain equation or an expression. So when you get this expression, this is 4 by m square and minus 1. The next thing will be ds by dm should be equal to 0. ds by dm equals to 0 means 4 by m square equals to 0. 4 by m square minus 1 equals to 0. 4 by m square equals to 1. M square is equal to 4. M is equal to plus minus 2. M is plus minus 2. Now you tell me whether we can take 2 or negative 2. We have to check for both of them. The fifth thing is we need least, and we'll check for the least. For that we need to double differentiate. So 4 by m square minus 1 was the first differentiation. You need to differentiate 4 by m square minus 1 again. It is minus 8 by m cube, and this is the double differentiation value. First you have to check for m equals to 2, then we will check it for m equals to negative 2. And we will try to take only that value, or we will definitely take that value which gives us positive. Positive means least, negative means maximum. When you place this, what do you get? You have this as a negative 1, this is less than 0. This is your maxima. When you have this minus 2 whole cube, you will get minus 8, negative cancel, you will get a plus. So this plus is greater than 0. Minimum it is. So you get maximum and minimum. What are you going to use? Least means maximum you have to take. So for that, you have to take the plus 2. M equals to negative. No, it's going to be one value which has given us the maximum value. For that, you can take 2. Okay. This value has to be placed here. In this equation, we have to put this negative 2. Because for negative 2, we have got this greater than 0, which is minimum, right? That's why negative 2 is what is to be placed in the original equation. And this equation gives you 9. So what is the answer? This is 9. So this is, I placed it in S actually. So just try to go along with the diagram. Once the diagram is clear to you, all other things you have been doing since the first question of this exercise. Total page of area 150. The combined width of margin at the top and the bottom is 3 cm and 2 cm. What must be the dimensions of the page in order that the area of the printed matter may be maximum? Alright. You have a page not like this, but just imagine that this is a page, A4 page. The first thing we are going to do is we will take X as the length, Y as the breadth. X length, Y breadth. So this is the X length and this one is Y, which is breadth. You can take any of it. You can take X also in the place of Y. It's up to you. And now I'm making an area where actually the content will be written or printed. So the other part will be only blank. This is the printed area. And what is the top? Top total margin is 3. So this is X. Just call it as, because there will be margin on both the sides, top and bottom also. So X, you have to subtract 3 so that you get the actual printed space. X minus 3. And what about the 2? That is this one. Call it as R and S. I'm just saying it because you understand what I'm trying to do. R plus S is 2. P plus Q is 3. So you have to subtract this 2 from Y. Y minus 2. So X minus 3 into Y minus 2. But before that, we already have total area of the page. So X into Y, we already have it. And this is already given as 150 in the question. The total area. We can get certain relationship between X and Y. You can call it as Y equals to 150 by X or X equals to 150 by X. We are very good and very well versed with X. So we always take X on the right. So that when we differentiate, we only get X. What about area of that space where printed content is going to be printed? Means the area which is actually of any use. Other part will be blank, which we call it as margin. So the area is length into breadth. Now the area becomes X minus 3 into Y minus 2. Multiply them. And when you multiply them, you see X into Y is what? From equation number 1. No, from equation number an equation which is higher than or written above equation number 1. X into Y is 150. So in place of X into Y, just write 150. Minus 2X minus 3 into this 150 by X. And this is plus 6. This is your area. Just differentiate it now. dA by dx is what you need to perform. The constants are going to be 0. Minus 2x is negative 2. And this 3 into 150 is 450. This is going to be 1 by x differentiation is negative 1 by x square. Next one will be what? You have to equate it to 0. So this is going to be 0. Negative 2 plus 450 by x square is equal to 0. So you get 450 by x square equals to 2. X square is going to be equal to 450 by 2, that is 225. So x square is 225 here. So 2x square is 450, that's what, and you know already the under root of 225 is 15. So that's what we are going to get it now. X square is 225, so x will be equal to plus minus 15. Now tell me, are you going to take a negative value? No, we can't. The distance cannot be, or the length cannot be negative. So we are definitely going to go with x equals to 15. How about y? Y is 150 by x. 150 by x is 150 by 15, which is going to be 10. So you already got the answer. This is the answer. X is 15, y is 10. Now you have to show one more part, which is the maximum part. So once you go along with this, you have to differentiate it. And so I'm double differentiating it right now. When you double differentiate it, this negative 2 will be 0. 450 by x square, so you just have to differentiate 450 by x square goes up, x to the power minus 2. You will get this differentiation as negative 900 divided by x cube. You put x equals to 15, that is going to be x value, because we have just discarded x equals to negative 15. So you don't worry about the number, you worry about the sign. When it is less than 0, you are definitely going to get the maximum. So maximum you are going to. What is the maximum? At x equals to 15, y equals to 10. This is your answer. And if you do it or perform it using the diagram, solve it using the complete diagram, margin also shown, it will be easier for you. The space S is described in time t by a particle moving in a straight line is given by this one. Find the minimum value of the acceleration. Now this question is related to an earlier question which I told you that the equation being given, just don't go about differentiation and double differentiation. You have to come up to the question. Question is saying acceleration. S is distance, ds by dt is velocity, d2s by dt is acceleration. So we have to find the minimum value of the acceleration, not the s, not the distance, not the space. I hope you got the idea. So you have to double differentiate it, then a will come and then you have to start the question. That will be the beginning of the question. What I am trying to suggest here is s is equal to t raised 5 minus 40t cube plus 30t square plus 80t minus 250 ds by dt is your velocity. The differentiation is quite clear to you. You already know it. It's 5t raised 4 minus 120t square plus 60t plus 80. Why did we get this? Alright. Now this ds by dt. This is velocity. Still we haven't reached the start of the question because the acceleration is d2s by dt square, which is dv by dt, which is the acceleration. Acceleration is the rate of change of velocity and velocity is the rate of change of distance. We have 20t cube minus 240t plus 60 is the differentiation. Here the question will start. Don't worry about the two equation in the when we wrote the two equation in the first and second line. Third equation is the actual thing. So now you will differentiate this one. dA by dt is the actual differentiation. And this is what we are going to equate it to 0. 60t square minus 240 equals to 0. 6 4s are 24. You know that you are going to get 4t square equals to 4. So t will be equal to plus minus 2. Can the time be negative? Never. Until you go to some, time stamp or some technology which takes you earlier. So t is plus 2, now we are going to double differentiate it in order to show that it is the minimum value. d2a by dt square is the differentiation of this one. 60t square minus 240, you got 120t. So when t is equal to 2, it's 240 is greater than 0, you are going to get minimum. It's minimum, alright. In order to get the minimum value, where do you put? First equation, second equation? Tell me. Yes, in the third equation, because the acceleration is actually 20t cube minus 240t plus 60. This equation, call it as equation number 1 because this is the actual equation from where you need to start. So t equals to 2 is 220 into 2 cube minus 240 into 2 plus 60. And this gives you acceleration as, acceleration can be negative positive, right? So the car is going to be slower and faster with respect to the acceleration. So you get a negative here. So that gives you the acceleration value. So first differentiation of the original equation, second differentiation of the original equation, then you come to the third equation and that is from where you have to start. So whatever we discuss is in front of you and this is the written material which you need to follow. Alright. Now there is a good news for you. The good news is these are 46 questions. But they are very strong questions. Every question needed a lot of effort and every question, if you have understood, I think that this chapter is clear to you. And so this is the last question. This is the good thing for you. And if you understood all these 46 questions, this chapter will be very easier for you in your later coming exams. And you will be saying, don't talk about here and there. Tell us how this question is going to be solved. So let us get back to the business now. Distance at a time t is given as like this. This is distance. Find when the velocity is maximum and acceleration is minimum. Don't worry about minimum and maximum. First worry about the velocity and acceleration. Since s is the distance, ds by dt is velocity and d2s by dt square is acceleration. So the differentiation of the distance is velocity. We are going to take this original equation which is t raised 4 by 4 minus 2t cube plus 4t square minus 4 So velocity is ds by dt. This is velocity. What is the differentiation? It's quite clear to you. It's a very simple equation. The logic of this solution may be important to you, but the differentiation, if you already completed differentiation chapter, it will be easier for you. So I've now differentiated the distance, which is the velocity. Let us find out the acceleration also. Just differentiate the earlier equation. So I'm differentiating t cube minus 6t square plus 8t. You get 3t square minus 12t plus 8. First, we have to check for the velocity. So velocity and acceleration will be dealt separately. So dv by dt has to be equal to 0. Then you will get the critical point. Again, dA by dt has to be done. But let us only concentrate on dv by dt. This 3t square minus 12t plus 8 equals to 0. This is not an easy equation. You will not be able to solve it. You have to use the Sridharacharya formula. I leave it to you because you know that minus b plus minus under root b square minus 4ac by 2a is what will give you 2 roots. If you are not able to make the factors, because it is not possible in here, so you have to use this Sridharacharya formula. Let me tell you the final values which are going to come. So it will be 2 plus minus 2 by under root 3. Here a is 3, b is negative 12 and c is 8. Use all of this. Now d2v by dt square double differentiation we have to do. What is the double differentiation? 3t square minus 12t plus 8. And this is the double differentiation of the, basically the differentiation of dv by dt has to be done d2 by v by dt, which is actually the acceleration. But don't worry about this, because here you are going to put 2 plus minus 2 by root 3. And you have to place both the values, 2 plus minus, both plus minus has to be kept in this d2v by dt square in order to get the negative and positive, so that you can reclaim or claim that you are going to get the minimum or maximum velocity. You are going to get maximum velocity for sure. For 2, please remember both of these. I am just showing you for what value you are going to get maximum, but the other value has also to be placed here. So d2v by dt square is 6 into t, 2 minus 2. As I said, 2 plus 2 by root 3 also has to be kept. But I am just showing you 2 minus 2 by root 3. You are going to get a negative. Negative means less than 0. Less than 0 means you are going to get a maximum value. All done. Velocity thing done. What will be the velocity? Velocity is, you have to place this value minus 2 minus 2 by root 3 in the velocity equation, which is the equation number 2 here. Acceleration is what? You will start with the acceleration now. Acceleration, you have to differentiate. Velocity is done now. We have come to the second part of the question, which is acceleration. Differentiate it now, dA by dt. Once you differentiate, you will get 3t, 6t minus 12. You already got it in the second part. But you have to do it again, all over again. Just equal to 0, t equals to 2. So when you have t equals to 2, you have to place it in the acceleration equation. When you place this in the, because once you double differentiate, you are going to get 6, and which shows you definitely that it's minimum. Greater than 0 is plus means minimum. So at t equals to 2, you get this one. At t equals to 2 minus 2 by under root 3, you are going to get the velocity. So there are two values for which you get velocity and acceleration as maximum and minimum. And you can refer here also what we have done just now. All these things have been explained, but 2 plus 2 by root 3 and 2 minus 2 by root 3 both needs to be checked. I just told you 2 minus 2 by root 3. That is just for my saving of time. But you have to, as a you have to do it, all of it. So all of this has been done. Thank you so much. Have a good one.